you will have a better energy efficiency. So therefore, future, if we go for a complete hydrogen, see if we increase the hydrogen content up to the 100%, then it will become hydrogen fuel. And these fuels are most important for the mobility. So which we are now talking about electric vehicles and so on. So you see that future would be electricity and hydrogen are the major fuels for the mobility. But then how do we produce them is important. The production of these fuels are carriers, energy carriers through renewables would be a better option. Otherwise, if we use them, if we use the fossil fuels for conversion of either electricity or hydrogen, it's again will have to face the environmental issues. So therefore, it's a sustainable idea of converting renewables into either fuels or energy carriers. Of course, there are various methods by which one can convert these into the secondary form of energy carriers. So I have listed out here there are 2-3 energy system conversion systems, mainly electrolysis and SMRD carbonization and so on. So if you look at the world in the night, globe in the night, it looks like this. There's a lot of energy demand and prosperity. Wherever it's highly illuminated, this is a night picture. When you take photograph night time of the globe, it looks like this. Wherever it is highly illuminated, that means you have a high energy consumption or energy demand. Or of course, when you have energy consumption and demand, obviously you have a more rich or more prosperous. So therefore, wherever it's lightly illuminated or less illuminated, they are under energy poverty. So this map shows the energy poverty. You can see that the previous map and this map. And so if you see mainly this region, SARC region, which covers India, Pakistan, Nepal, Bangladesh and Sri Lanka, still there are several million people do not have access to the electricity. And you know, the primary energy I have shown in the previous slides, the primary energy is very important. So for human survival, basically 3 important things are important requirements are air, water and food. Somehow we are getting air free of cost, though it's highly polluted, but still we are not paying for the air. But whereas the water and food, we are still paying, and because water, we cannot use it from the natural sources. So there is a huge energy requirement for treatment and so on. And but the food is available naturally, but we cannot eat. But the food requires processing, and the basic food processing is the cooking. So now if you see that still in these countries, many people are still dependent on biomass for the food processing, that is a cooking application. So therefore, there is a huge potential for arriving a sustainable source. And you see that still about 1.6 billion people do not have access to electricity, and 80% of them are in South Asia and Sub-Saharan regions. So if you look at this energy context internationally, and there are change in global energy scene, and it depends on various factors. So those factors include these climate change, growing energy demand, resources nationalism, and of course the price volatility and OPEC role in energy sources, and geopolitics, and high energy prices. Of course, security of supply concern are major challenges at the present global energy scene. So these are the factors which influence mainly energy goals and drivers. The energy goals are we referred as 3A criteria: accessibility, availability, acceptability, and the drivers are GDP, energy demand, energy supply, and these goals and drivers are closely related by these demography, environment, institutions, and prices, technologies, and through these goals and drivers. But though I mentioned 3A criteria, that is accessibility, availability, acceptability, but there is this is much bigger than this. Those includes 6A criteria, which is accessibility, affordability, acceptability, adaptability, and of course appropriateness, assurability of the energy sources for given energy demand or energy supply drivers or GDP drivers. So therefore, in order to have these energy sources, and if you look at the global outlook, it's be a most important fossil, of course, the present energy scenario is driven by fossil fuels. Those fuels include coal, oil, gas, and of course nuclear. As far as the India is concerned, we import all the energy resources. We import coal from Indonesia and Australia, South Africa. Oil, you know very well, Middle East. Gas also from Middle East. Nuclear again from Australia and other. But though we have a very limited nuclear installations, most of the energy is being supplied is based on the fossil fuels. So the energy sources for mobility is very important, which is the present topic of interest. So I will try to concentrate how the energy sources are important and what are the developments in electrical vehicles, and mainly the activities that are taking place at IIT Madras in our group that I am going to highlight now on. So the oil for mobility, energy source for mobility is the oil, and of course to some extent gas, but oil is very important, and its present scenario is based around oil as a fuel. If you look at global energy, global oil reserves estimated about so much, about 1147 billion barrels, and you know very well how these are distributed. This distribution of oil is not uniform, so therefore you know that India still import a lot of about 65 to 70% of the oil is imported from Middle East and other countries for our mobility applications and other utility. So the crude oil prices are highly volatile. The prices range from, of course, we have seen once about $140 to $150. Now it is moderately less because of the supply demand relation. So of course there are potential mainly developing countries because where we don't have much oil reserves in India and the developing countries. So therefore the import is primarily driven by import. So therefore the consumption is day by day it's increasing. So therefore it's very important to take care of these things. And of course, we have seen several oil price shocks, or we call embargoes, in past, and which result in energy efficiency. And that's why we can see that now all modern mobility vehicles are relatively better efficient, and so therefore there is a lot of scope for improving the efficiency, and also parallelly looking at the emissions and so on. And the current oil reserve to production ratio, what I mean to say here is that the oil is limited and it can last only a few years. So the present reserve to production ratio can be somewhere close to 40 to 43 years. The present reserves can last about 45 years if you consume with the same rate, and of course it's not uniform throughout the geographical locations. In some locations it's higher and some locations are it's very lower. As far as the India is concerned, it's very limited. So therefore one should really look at the alternative options for mobility, and the electric vehicle option would be one of the attractive options. And if you go for these oil scenario, we have a technology which can drill deeper and deeper, and then we can exploit the resources from even deeper, far deeper reserves. But again, the cost and economics is a major issue. So here you can see that the present technology can go up to 1.7 kilometers deeper, and you can still drill it and get the results. So what we feel that these oil reserves and resources, based on this, we develop our mobility vehicles. And see, these are some whatever I've shown you is one of the premium or luxurious vehicle, and we want this if we can afford it. If we buy it, we can do that. But you know that this technology is not an Indian technology. So even if you have money, we can buy it. And if you want to drive this particular mobility vehicle, and we need fuel. The fuel is also not, as I mentioned, that about 70% of the oil is imported. So therefore, most of these vehicles are driven by foreign oil. So this is not an Indian technology. So therefore, we have money so that we can afford to buy it. And we can also afford to buy the fuel which is not an Indian fuel. So we are using foreign fuel, foreign technology, and trying to operate these on improper or with poor infrastructure, mainly roads and other things, and which result in polluting Indian environment. So we are using foreign fuel, foreign technology, but polluting in Indian environment. So tomorrow, if we have a problem of supply of though we can afford to buy a car, but if there is no fuel for this tomorrow, if there is Middle East or some, you have seen now we are facing problems with the Chinese technologies and all. So similarly, if you have some fuel shortage, and if we are unable to get the fuel from abroad, what will happen to this mobility vehicle? So maybe eventually we have money, we can buy it, but we can run these vehicle on the improper roads, pollute them Indian environment. But if there is no fuel, what will happen to this? So we may have to land up into this situation. So if you have we feel that we deserve for this, but eventually if there is an unrest in supply, we may have to land up into this kind of environment. So energy sustainability is very important, and we have seen this earth, it is looking very bluish color and very nice, but because of excessive energy consumption, mainly which is fossil fuel driven, and if you use oil, coal, gas excessively, this earth is surrounded by the nice environment, but that environment gets imbalanced because of excessive emission of pollutants into the environment. Any imbalanced system is literally looking into this. You are just burning of the Earth's atmosphere and making unconducive or non-conducive for utility. So therefore, any overloaded system result in this fashion. If you put so much pollutants into the Earth's atmosphere, obviously there will be a significant imbalance, which we are facing currently. Right now, we are facing those imbalance into the system. So therefore, it is important to come up with a sustainable resource. And if you see that if you have resource here, and we can consume these resources without any technology, but the moment you start consuming, these resources will become empty sooner or later, once the resources are becomes empty and whose replenishment time is significantly high, so mainly the fossil fuels, then what happens is future generation may not have any fuels left for their use. So therefore, it's very important to develop a technology which takes care of your or our sources and keeping these resources for the future generation. So therefore, this technology is very important. So this technology which keeps these reserves for the future generation and attaining sustainability and using our own share, but this is important technology. So therefore, it is an important that we should develop our own technology or an indigenous technology, either for mobility or for any other energy consumption. So therefore, sustainable development is very important. Generally, it's a standard definition of sustainable development is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So this is a standard definition. So therefore, the energy sustainability is very important, and future generation says that there is only one earth we have to take care of. So therefore, we need to use these energy resources most judiciously. So therefore, developing indigenous technology is very, very, very important at this present scenario, whether it's go for mobility or some primary energy uses. So it's your money, your environment, your mission readiness. So therefore, you have to conserve your earth by going for alternative methods. And how do we conserve? Because of the electric mobility, which is a non-polluting or less polluting options. And therefore, the renewable energy option in smart cities are very important. So you can cover with various renewable energy sources across the city and try to use them for charging stations and for catering to the needs of the system. So if you go for mobility, then there's what we call alternative and transitional energy source for the transportation. That includes, based on the renewable energy for transportation, includes both transient with storage and only storage options. And you can see here that these transient options are very simple in construction, where active systems and lesser reliability and highly not suitable for frequent uses, and of course less maintenance, low capacity applications, and so on. Whereas if you go for transient and storage, we have relatively better reliability and active passive systems, and of course they are reasonably simple, and of course there is a possibility of storage and compactability, and for long travel, high maintenance relatively. But if you go for only storage, it's very simple. Only storage is a challenging and high reliability, and most of them are passive systems. And as I mentioned, that these transient are generally be used instantaneously, whereas transient and stores are used instantaneously as well as the storage options. And storage means completely based on storage. You convert renewables into required energy storage and use them. And the classification of these sources based on renewable energy is biofuels, fuel cells, hydrogen, wind and solar energies for transportation. And of course, wind, solar energies have been in practice for a long time for the mobility. Mainly one of the most ancient mobility application is the sea transport. And you know that the air or wind is used to drive these sea transport, and of course still some extent it's very important to use it. These are some of those sea transport like ships or boats for mobility application and transport applications. And you can see that ships using rotor sails, which can drive these well, a larger distance. This is a Magnus effect is used mainly. It's a wind turbine effect, vertical type of wind turbine, which are used to move from one location to the other, but mainly in sea transport. And there are fixed wings with the solar PV hybrid panels. You can drive these sea transport with solar panels as well, and they are now becoming popular. And we can still use solar energy for long-term or long-range mobility applications. And biofuels also very important. They are also referred as carbon neutral fuels, or biofuels as a renewable source. We have wide variety of options for bioenergy conversion. Generally, the biofuel is produced mainly from the sun. Biofuels are also manifestation of solar energy. You can see sunlight, carbon dioxide, water. Photosynthesis is the major process for converting solar energy into biomass, and this biomass is converted into various cultivatable and non-cultivatable biomasses, and of course some waste. And ultimately, you can convert these into the useful fuel, which can be even blended with fossil fuels and so on. Then biodiesel is one of the important options for this, and I have mentioned that this is a complete carbon cycle. We call circular economy. The circular economy results in completing the cycle, and that includes various blending of biodiesels with the diesel fuels. And of course, you know that in India, Indian Railways using larger extent the biodiesel, and which can be even stored and used safely at relatively higher temperatures. The demand is growing mainly for traffic and transportation, and climate change is the major concern. And also there should be some good agricultural support, energy security, and biofuel have a good role in the mobility applications. And there are a lot of countries there are several countries which are using this biodiesel into a commercial vehicle. And you can see that this biodiesel plant in Kakinada for Andhra Pradesh, you can see that one of those plants for biodiesel vehicles. Fuel cell technology is a kind of a hybrid indirect electrochemical devices which converts chemical energy of the fuels, mainly hydrogen, which I mentioned. The hydrogen is the highest form of fossil fuels. So if you have a hydrogen content higher, it would be better. So therefore, it reacts with these. And then of course, there are a wide variety of fuel cells which can drive the mobility vehicles or transportation vehicles. Some of them are listed here, and which includes FEM fuel cell, of course phosphoric acid fuel cell, and solid oxide fuel cells, molten carbonate fuel cells, and protonic change fuel cells. These are some of the fuel cells which, depending upon the capacity and the operating conditions, mainly temperature and other parameters, are used. But I am not going to detail how they are and all. So this is one of the, in fact, a couple of days, 2 days back, I've seen the Hyundai has developed a fuel cell truck, which I think is the world's largest fuel cell truck, it seems. And this is one of the hydrogen-based fuel cell car. I'm not going into detail, which actually the fuel is hydrogen, and it is converted into electrical energy by a fuel cell. And of course, this electrical energy is given to the electric motor, which in turn drives the system. So therefore, it is not directly electric, but the energy stored in the form of hydrogen and subsequently converted locally. And of course, this is one of the good options. But we can also have a transient form of energy we can store in batteries, or we can also store in the hydrogen, or we can have a mixed combination. These are some of the fuel cell based cars, not only cars, buses and trains Alstom also developed a fuel cell based train and so on. So therefore, there is a huge potential. We have seen in sea transportation. This is surface transport, and of course, not only sea and surface transport, we have also transport in air. That is the aeroplanes based on the hydrogen fuel cell as well as the electric mobility. I have given here some of those details in this. It's a small passenger aircraft which can accommodate 4 people and with some reasonably good range of flying, and which can be used for this. So therefore, eventually it has to be popular, and this one. And another important mobility is this impulse. So solar impulse is one of the good attempts to make use of the solar energy for mobility. And this is the aircraft developed and demonstrated, and it was run complete one cycle of the Earth. It went around the Earth once with different stops, and in India also we had some stops, maybe Ahmedabad and Varanasi, other locations. And this is also an important mobility application, electric mobility application, to demonstrate air transport and effective way without dependent on the fossil fuels. So these are generally available literature, but at IIT Madras we are also working in various indigenous technology developments. I will list out some of these, and I will also list out one electric mobility vehicle which we developed at IIT Madras. Also I will show. Our main, my group mainly focuses on the indigenous technology development. As I mentioned that if we develop our own technology, it will be useful for India, and we can generate economy, or we can generate revenue out of our own technologies, and we can use them for Indian conditions. So as a part of that, we have developed about 20 technologies. They have reached it to the commercialization state, and some of the technologies have already been commercialized by our industrial associates, and they are in the market. Our main approach is called 4D approach: design, development, demonstration, and deployment. And it is through, there is a concept called 4E analysis, and of course the development through 4 to 60 approach. See, design, development, demonstration is the key approach, and 4E is energy, exergy, environment, and economic analysis. So therefore, 4D through 4E based on 4T. 4T means this is T, first 2 T's are TT, that is a test tube kind of 4D approach. Once you have test tube, means very small and more of a miniature type of systems. Then 4 table test tube to tabletop, that is the tabletop technology. Then of course technology demonstration. These are the various stages of technological evolution. And as a part of that, I have shown here 20 technologies. But now I will show you these technologies, how quickly, how we are working on these technologies, how we develop, and how they are evolved and reach to the stage of maturity and commercialization. And this is my group, and of course this is my lab, Solar Energy Research Lab, and we are working on various concentrating and process heat systems for this one. This is another view of our lab, and we have developed concentrating solar technologies, including solar dish, and I have listed out here with the 20 square meters, and subsequently we have gone for higher dishes and higher solar systems. We call 4G dishes, solar desalination and PV systems, and parabolic trough collectors, and concentrating photovoltaic systems. And I have given here their ranges. and most of these are, as I mentioned, that technology demonstration scale, and our 4D approaches make these systems to deploy in the field directly. So most of our our systems are at the technology demonstration at the lab itself. So therefore, they can be easily taken to the field. These are some of the technology. You can see that with respect to this person, they are reasonably bigger sizes. So therefore, most of the operating characteristics are evaluated at the lab, and then they will be taken to the field for integration and subsequent commercialization. So this is another view of our systems. Like you have integrated collector storage systems, ETC systems, and flat plate desalination, and big dish, and so on, trough. And these are some of these my industrial associates who commercialized our systems. So you can see that this is in a pharmaceutical industry, this is in another industry which are placed, and these are the brochures for their marketing and publicity. Because as I mentioned that for mobility, the hydrogen production is very important. So we have producing hydrogen from renewable energies is very important, not fossil fuels. Again, if you produce from the fossil fuels, again you will have environmental issues there, and conversion efficiency is also very limited. Whereas if you go for renewables, produce hydrogen through renewable energy, we have done some attempts to produce hydrogen from like here in this case methane. Methane is produced from biomass, and methane is supplied as a feedstock, and then methane is split into carbon and hydrogen, and then carbon is used as a black carbon, and which is a byproduct. Hydrogen is a fuel which can be used for mobility applications. And we have developed this reactor for solar energy applications. And you can see that this is the solar dish, which we call it is which concentrates solar energy into focal region, and then subsequently to convert into superheated steam or hydrogen. And this is another view. You can see that the flux is distributed here. This system is installed in a pharmaceutical industry in Hyderabad. We have also come up with this parabolic trough collectors. This is another lab, my lab 2, extended lab. And here we are using the solar system. This is for process heat application. This is power generation. So, and it's a power plant, mini power plant in our campus. This is located in the fourth floor terrace. So we have seen this. You have seen this. We have lifted up to these and made base to that. And another technology which we implemented in a school, which we call Pathashala campus near Kanchipuram district, Vallipuram. And this is a solar with a storage, I'm sorry. Storage. You can see here, these are the oil and water storage, and this can cater the needs of the school, not only electrical needs, but also heat needs. There is a process heat for cooking and other process heating applications like utensil cleaning and air conditioning applications. This is about 70 kilometers from Chennai. And we have been working actively on development of CSP in various, these are our simulators, in-house simulators, which can even go up to 50 bar and 400 degrees Celsius. This is another system which our industrial associate installed in Coimbatore, which can produce the steam. You can see that. And this concentrates solar energy into heat and then subsequently steam. And this steam can also be used to produce hydrogen for mobility application. You can see that here how steam is coming out of this. And further developments on dish for PV, CPV and hydrogen applications. And this is another hot water system which is used for converting process heat, and then with the minimum losses and so on. And this is a solar panel which converts solar into electrical energy, but we developed a simple tracking system which can track this sun from morning to evening, which results in higher outputs and so on. And this is the tracking mechanism which is developed by us, and one of our undergraduate students is involved in developing this. And this is a concentrating photovoltaics, which is a cogeneration or trigeneration system in which we can produce electricity as well as the heat or even cold or water desalination. This is another reflecting type of refracting type of systems which focus on here, and then it is subsequently used to convert electrical energy through these triple junction solar cells and so on. And process heat application is very important. So we have developed a process heat system which is which converts solar into process heat, and maybe for desalination and potable hot water production. As I mentioned that apart from food, water, air, water is also very important. So therefore, water is not available in a natural reservoirs or natural bodies, water bodies. So therefore, we need to treat it. So therefore, we have come up with a desalination system which converts seawater into potable water and so on. So you can see that this developed system, it's a multi-effect desalination system which can handle even not only wastewater, not only seawater, but also wastewater, and which can easily produce better water or yield, which can even range up to 50 liters per meter square per day. And subsequently, we came up with another desalination system. It's called vertical seal. It's a simple seal. Generally, this is employed for on board. See, when these fishermen, they go into the sea, and then they need water. So therefore, we can produce on board water by using such systems, maybe in boat or so. And this is another flat type of desalination system. It's a solar still with staggered basins. So therefore, multiple basins are used, and whose efficiency is much higher, and so on. And this is one important thing. Presently, India is mainly focusing on indigenous technology, Make in India, and mainly Swachh Bharat, Clean India, and so on. So as a part of that, we have developed a solar system which converts human waste into fertilizer, and then it is used for treating the solid municipal solid waste and so on. And as a part of that, we have developed a kind of, I will show you it later. We have developed a net zero discharge, zero solid, zero liquid discharge toilet under Swachh Bharat scheme. So this another one is the textile effluent treatment by solar energy. You can use solar energy for treating textiles, textile effluents, and you know that India is the largest exporter of textile, and of course it produces a lot of textiles. There are several textile hubs, and they generate wastewater, but that wastewater is now being rejected into the fields, agricultural field, which results in land pollution and so on. So therefore, in order to the now present Ministry of Environment has stringent norms, and so therefore, in order to cater the needs of that, we have developed this and installed in Tirupur, which is a textile hub, and in order to treat the wastewater from produced from the textile industry. And now for a habitation, you mainly you know that this residential sector energy consumption is substantially higher. And so therefore, we have to come up with an affordable net zero energy buildings where the building itself is an energy source as well as a consumer, so that if we come up with a modular structure for this kind of environment is very important. As a part of our Indo-Canadian project, we have developed net zero energy building, which consists of solar panels and windmills and of course waste treatment, solid liquid. This is completely pollution free. There's no energy coming and no energy goes out. There can be possibility of energy going out, but there's no a solid waste or liquid waste going out of this. This is one such system. It's a conceptual I am showing. A real system is under construction, and this is a typical system. As I mentioned that as a part of this cleanliness, we have developed a net zero discharge toilet, and it's installed in one of our students' hostels. That is a Krishna hostel, and this doesn't liberate neither liquids discharge or solid discharge. So therefore, complete liquids and solids are recycled and used for internal purposes, and it's completely hermetically sealed. There is no smell or nothing will come out of this. So this is we have already commercialized and given to the industries. The another one is an integrated renewable energy system, which can be used for mobility applications also. This we have installed in a village which is close to Shantiniketan, that is in West Bengal, that Rabindranath Tagore's place. And this system, which includes biomass, batteries and solar panels, and of course it's an integrated system. The biogas is used to drive this engine and then produces electricity. So we have developed complete control systems for this, and this caters a village which do not have any access to electricity. About 60 families are using this, and it's working well. And these are complete grid integration system with biogas and other things. And this is the mobility development of solar powered electric auto rickshaw. It's an electric vehicle which we developed to run this using solar panels which are on the top of this. I will show you the details. This is one of the important electric mobility application, and mainly this is a development including structural analysis, then aerodynamics, as well as the power supply and distribution, energy storage. Everything is controlled in this, and the system has been modified according to these parameters. And here I have listed out what are the different types of thing: panels, MPPT controllers, battery bank, and motors, and other details of this. And it involves both mainly driving the motor and driving the wheels with panels. Solar panels are the electricity produced from solar panels is controlled, and then sometimes directly used, and sometimes it's stored in the batteries. And so eventually you run completely this on solar technology. So therefore there's a brushless direct current electric motors are used, and MPPT is a maximum power point tracking system in order to get the maximum output and so on. The motor controls are important. Some of these controls are, you can see here, this is axial with motors with a BLDC motor, and these are controllers, and all these are assembled. Everything is assembled and made into a single system. And these are some of these components of the mobility vehicle. This is the auto suspensions, telescopic, and motor. Rating is about 1 kilowatt. Batteries, this lead acid batteries are used. We use lead acid batteries, but we can also use lithium ion batteries, which maybe only the difference is the weight. Specific energy density is very high in case of lithium ion, whereas lead acid we have less specific energy density. And these are chassis, and all these are made like mild steel tubular chassis and high performance fiber, and all these deep discharge batteries used. And you can see that how this is built, and the structural, and one of my MS student worked on this and developed this slopey roof where we can place these panels, and the aerodynamics is studied, because if by placing these panels, if the drag is significant and it may consume large amount of energy which is produced. So therefore we should have a minimum drag, so that accordingly the stability is also improved. So, and with a minimum energy consumption and so on. So we have done this structural analysis of this solar powered electric vehicle, and we have seen how the energy charging, discharging with the time, and if you run in an annual basis, how do we produce from throughout the year the energy, and then it is compared and used here, and variation with different timings, and with the PV output, how it can be integrated with the mobility vehicle throughout the year. And because it's essentially we have to come up with a good economic model. And this is the performance analysis of the system. If we, because our students, they did a lot of load analysis by sitting, if there is no load, with 1 person and with some load, and 3 person and 6 person, how the battery discharge rate happens, and all this has been studied, and their respective mileage is also reported here. You can see that. And then accordingly, what is the power consumption and all those things have been studied. And then we have to compare with the economic model with the present options. The present options is these auto rickshaw. So if you compare with these two, in terms of not only energy point of view, but also cost, what we call 4E: energy, exergy, environment, and economic analysis. So environmentally also, how many tons of carbon dioxide is released throughout its lifetime, or if it works at 20 years of work span, and it has been compared in terms of energy and environment. These solar energy powered electric vehicle is more attractive as compared to the present options of this. So if we implement this with even further aesthetics improvement, I think it can be used better. So if you look at the economic analysis, as I mentioned just now, that there's a significant economic analysis. So therefore, the yearly income as compared to the gasoline based auto rickshaw, this is seems to be better. So therefore, we can see that the comparison between the solar vehicle as well as these from cumulative cash flows. So therefore, there is a good option revenue generation out of the these electric vehicles with reasonably good, and we'll have a see payback somewhere comes about 3.5 years, or maximum 4 years you can reach the payback and so on, and whatever is the rest is the profit. So therefore, and the payback period is completely, this is touching faster. So therefore, the payback duration is about 24% lesser than that of this one, and you'll get higher. This income also in entire lifetime, the income, annual income is also better as compared to this, because the input cost is low. So therefore, the overall energy efficiency is higher. Then in turn, the income on the system is also improved. So, and of course, it's also compared with environmental impacts with CNG, gasoline, and LPG driven vehicles. And these electric vehicles will have a minimum environmental impacts. And so you can see that the vehicle lifetime, if you compare with 20-25 years lifetime, then the emissions produced are substantial per unit liter of fuel. You can see these numbers are given here. And so therefore, on a yearly basis, the carbon dioxide mitigation through these electric vehicles are very important. And you can see that so many number of kgs of 153 kgs by considering this about 3 kilowatt hour per day, and of course 300 days and so on. So therefore, electrical mobility is very important, and you can see it looks like this. And see this when they are doing load test. Some my students, they sat here and tested in the campus. And if you have a clear-cut comparison, which I have shown here, this is the summary of that. So based on the input parameters, the payback period found about 4.5 years for the gasoline, whereas 3.4 years for the solar powered vehicle. And as I mentioned, that it gives lesser payback and more energy output. And these are again specifications which I have already shown. So you can see that mainly solar panels are placed on these, and because this also improves the stability and performance as well. And these are, you can see that these are specifications of the battery and whose efficiency is shown here, and the motors, and as I mentioned, there is 1 kilowatt motor and so on. So the advantages of this is zero greenhouse gas emissions, reduction in energy cost, and noise is also relatively less, and unlimited source of energy, which is indigenous. We need not have to import from Middle East. The solar energy is available in India, so nobody can stop using the free solar energy. So therefore, nobody can shield the sun, our sun. It's our sun, though if it is not our oil, but it's our sun. So therefore, it's an unlimited source which can effectively be used for this either in electric way or through hydrogen production and so on. And this is my group which used, of course, they are involved in developing our technologies. And most of them are my PhD and MS and undergraduate students. These are most of them are MS and PhD students alone. So we have a big group in developing this. And I think with this, I think exactly 1 hour I've completed this. And thank you so much for your patient.
Thank you, sir. Thank you very much, sir.
If you have, I will just give a few more words. And I think there are a large number of participants. I hope you have seen, you have visited, some of you have visited IIT Madras. I'm from IIT Madras, and IIT Madras is a huge campus with a lot of, you see that these animals and our friends. We have not only the deers, we have snakes. It's a reserve forest. Yes, snakes, monkeys, and so on. So you have seen this last slide, and this my friend is looking for you, looking at you for looking at these questions. If you have any questions, please feel free to ask to this person. I will give answers on the person's behalf. Thank you so much.
Thank you, sir. Thank you very much, sir, for your wonderful lecture. So we can give a broad aspect, importance of renewable energy. When we can think of electric vehicles, we don't think of fossil fuels by generate electricity, and that electricity we can use for electric vehicles. That is not only that is not the option. We must go for renewable energy to generate power, and that power only we can use for electric vehicles. Then only we can able to reduce the energy cost also. We have, I think, from my side, a small question, sir. So actually, we can see several prototypes or several vehicles throughout the globe we are developing, especially coming to the four-wheelers, the cars. So how can you able to improve the aesthetic improvement without compromising the performance of engine, or engine, not in the sense performance? That means we have seen several models which require a large amount of solar collector area for receiving, and we can able to use it to the battery and then to the motor. So without compromising aesthetic look of cars, so what type of panels we may prefer in future, or anything in that area going on services, going on anything?
So I have shown here in my my presentation that one example how we can make a solar auto.
Yes, sir. Yes, sir.
But larger extent, it's not good because see, this is a semi-commercial vehicle in which there is a reasonable time of ideal time and usage time. So therefore, we can directly integrate to the vehicle. Whereas the cars and other mobility vehicles, it's very difficult to integrate within the system. So therefore, there is a different business model. Generally, now you have seen these EVs, electric vehicles, are coming up with a battery storage, and there is now some of our known industrial associates, they are coming up with a different business model. Most of these highways, they are planning to set up like petrol pumps. There will be a solar charging stations where the roadside will have a charging stations for the vehicles, and maybe some 10 kilometers away where the land cost is cheaper, they can install the solar panels and then bring that electricity and supply to these vehicles where it can be like a solar charging stations on the road along the highways and even smaller roads as well. So that is the option actually. We cannot integrate rooftop type of systems into the automobile vehicles because as I mentioned that the energy may not be sufficient to travel for longer distances. Rather, it's better to charge it through solar energy rather than integrating it. And second thing is, as I mean, you have also pointed out, the aesthetics will play a major role because nowadays the vehicles are depending upon the personal taste. So therefore, some may not would like to have these panels on the roof. So therefore, that's a major issue. So therefore, it is better to integrate with a source rather than integrating the system within the mobility vehicle.
Thank you, sir. Thank you very much, sir. We have some questions from participants, sir. First, Nawaz Basha. So please unmute and you can ask question.
Hello.
Yeah, please go ahead.
Hello, good morning, sir.
Good morning.
Hello.
Hello, can you hear me?
Sir, we can. Hello.
Yeah, I can hear you. Please go ahead.
Sir, we can use PEPL-based thermal storage in solar panel, sir. We can use thermal-based solar. PEPL thermal storage is there, no? We can use for better efficiency. We can use, no?
No, thermal storage is a heat storage, is it?
Yes, sir.
Heat. What is the purpose of heat in mobile vehicle?
Sir, for increasing the efficiency, sir. In solar panels.
No. Actually, that heat storage is different from electrical energy storage. You know that most of these vehicles, there's an electrical energy storage. Either, as I mentioned, that you can go for hybrid fuel cell model or completely battery driven electric vehicles. But the thermal storage is not, there's no use. But thermal storage can be used for comfort conditions, like where mainly these cold weathers. You can use that for space inside. You know that we may need air conditioning within the vehicle. So for that, air conditioning need not be always cooling. It can be also heating purpose. In such case, this thermal storage based energy can be used for space conditioning, but not driving the vehicle.
Okay, sir. Next question from Ankush.
Hello.
Hello.
Am I audible, sir?
Yes.
Hello, sir. I'm Ankush Devsan from Nagpur.
Yeah.
Sir, my question is, sir, for that auto vehicle, which software you used for analysis, and is you consider any driving cycle for that?
Yeah. I think there are 2-3 different softwares, but for the solar panel, it's I think Homer software, and for loading and other thing, we have in-house. Our students have developed some software which takes care of the loading and this one. Your question is what is the loading cycle?
Yeah, driving cycle. Is there, you consider any driving cycle for that testing of that three-wheeler?
Yeah. You have seen that while testing it. I have shown that they have, in fact, our students have done extensively these driving cycles within the campus with different roads as well as different operating conditions, the different road profiles, and so on.
And sir, one more question is that the use of solar panel is cost effective or what?
Yeah, I have shown that it's a cost-effective option.
Okay, sir. Thank you, sir.
And it also gives some stability, because sometimes if you go for at higher speeds, stability is another issue. It will also give some stability.
Next question from Dr. Suresh.
Hello, sir. Can you?
Hello.
Hello, sir.
Yeah. Dr. Suresh, please go ahead.
Hello, sir. Can you hear me, sir?
Yeah. We can.
Sir, my question is, sir, the different solar, we have many solar technologies today in the market, and sir, which particular technology you support and you foresee the future for that? Because we have solar tubes, we have solar panels of different crystallines, and we have many more solar technologies, convection technology, we have conduction technologies. And sir, you foresee which technology will be the feasible solution for our future solar applications, sir?
Okay, I think the solar, as far as the solar is concerned, there are two types of solar energy conversion. One is you can convert solar energy into electricity, that is through solar panels, that is photovoltaic panels. That is one category. The other side is converting solar energy into heat through various devices like flat plate collectors and concentrating collectors and so on. So if you go for energy, direct energy conversion from solar to electric, there are different types of solar panels are available, and they include the single crystalline, multi-crystalline, and amorphous, and now we can say perovskites and triple junction solar cells. So you know the solar cells which are used in satellites, they are triple junction, multi-junction satellites, because the multi-junction solar cells, these solar cells we can capture wider range of solar spectrum so that the efficiency is better. The efficiency can go up to 40% also. So using for high efficiency solar cells is very important. And nowadays these perovskites and all, they are not efficiency, they may not be very efficient, but the cost is much lower. That is a very moderate cost, but you will get better output. So therefore, instead of efficiency and instead of looking at efficiency, we can also look at economics. Also, the per unit cost is important. So that is for solar PV side. But the thermal side, we can use various concentrating collectors, including parabolic trough or evacuated tubular collectors and so on. That depends on the application, whether you are going for process heat application. We are working on various process heat applications like textile industry, pharmaceutical industries, agricultural, mainly agricultural dairy industries. The milk processing requires heating and cooling. So therefore, there, what is the application, what temperature, what pressure you use is important. There, generally ETC and parabolic trough collectors are better options. Yeah.
Thank you, sir.
I hope you understood. Before asking questions, please also tell at least 1 or 2 sentences about yourself, so that accordingly I'll answer the question. What is your background? Background means whether you are from...
Next question from Abhiram, sir.
Good morning, sir. This is Abhiram from RV College of Engineering. I am assistant professor in mechanical engineering department. Sir, my question is, to improve the aesthetic effects, can we have a kind of flexible solar panels? The panels, whatever we see, are all in rigid shape, like there is a skeleton and on top of it is placed. Can it be more flexible, like a cloth or something like that?
Yeah, it is possible. That's what now the perovskite solar cell. They are very flexible, and it can be wrapped around that. But there are some limitations also with that. But in principle, it can be done. There is no problem.
Can we have some coating technologies involved in that, something like that?
Yeah, coating technologies. And mainly what happens is when we go for aesthetics and when we go for integration, one is energy conversion and cost, but the other thing is the safety is also another important issue. You know that if you see any automobile, even car or something, the efficiencies are in the order of some 30% or so. So remaining 60%, if you see car weight is about close to some 1,000 kgs or something, whereas the people who sit in that cannot be more than 500 kgs. So therefore, when you drive these, and most of the fuel is used to take care of self weight. Why we go for higher self weights? Because at higher speeds it is stable, because stability is very important. So therefore we can go for flexible, but we have to look at the other issues.
Okay, sir. Okay. Thank you, sir. Thank you.
So next question from Venkatesh sir from BMS College of Engineering.
Sir, good morning, sir. This is Dr. Venkatesh, Assistant Professor of Mechanical Engineering, BMS College, Bangalore, sir. Sir, first of all, I thank you for sharing your so versatile experience by using solar energy. So the first question is, sir, my curiosity is, though we have so much theoretical background and lab setup also, so in your case, you have developed many applications by using solar energy. What is the main hurdle in India? We are not so much adopted solar energy yet. We are through, but we are not yet implemented, because the solar energy is the theory of it is we have reading from long back, from at least not less than 3-4 decades. That is the first question, sir. Second question is, sir, one application like water heating we are doing in our college, in my lab, for heat pump, by using heat pump for 1 kilowatt approximately. So what is the equivalent cost if I use solar heater for 100 LPS? So these are two questions, sir.
Okay. So the first question is why it become not popular so much in India? Is it you are talking about in academic institutions or in general fields, general utility? So if it is a general utility, it's growing now. I think there is a target by Indian government by 2022, at least about 100 gigawatts of electricity should be produced from the solar. But now a lot of solar farms are coming up and solar parks are coming up, and there are two reasons why solar energy is not very popular, means why we are not completely dependent on solar right now. Definitely in future it is going to be a big source. Why? Because now it's growing very rapidly, and the fossil fuels systems are now slowly, coal-based power plants are not coming up very well because of the renewables and their cost. So the cost has substantially reduced, but in spite of that, still it's expensive. So therefore, the cost is one of the parameters or factors for not becoming very popular. And apart from that, the solar energy is available only during daytime. The reliability is another major issue. Reliability means we have to work, we have to make the system to work throughout the day, but it is operational only during daytime. But we can make the solar system to work 24 hours with this energy storage. So if you compare with solar system and storage, it's more expensive as compared to the present situation. That is why that is one of the factors for not becoming very popular. So therefore, if you go for a mix of both, like daytime you can use solar, nighttime you can use fossil fuel based, that is also one option. Or otherwise you develop energy storage, either it is a battery storage or thermal storage. Mainly thermal storage is very important for large scale operations. So therefore, if one develops that and reduce the cost of overall system, definitely it will become an attractive option. Hopefully in another from 5 to 10 years it will happen. And the next question is, you have a heat pump in your college. You are talking about what is the cost of solar thermal systems based on 100 liters per hour, isn't it? So 100 liters per hour generally cost somewhere 15 to 18,000 rupees. That's the cost implications.
Thank you, sir. Thank you very much, sir. One last question from Krishna Verma. Krishna
Sir,
Verma.
good morning, sir. My name is Krishna Verma, sir. I am from CMR College of Engineering and Technology, Hyderabad. I am working as assistant professor in the Department of Mechanical Engineering, sir. Very good lecture and very informative session, sir. Very good. Thank you for this, sir. My question is, you have discussed elaborately about e-auto rickshaw, sir. You have discussed about various advantages and performance characteristics. I want to ask about what are the problems you faced with this e-auto rickshaw, sir?
Okay,
Any problems associated with this? Because nowadays e-auto rickshaws are not coming into the market widely.
Okay. So the main issues with these is charging and discharging cycles. Okay. So therefore, they have to be, the charging times are relatively higher because throughout the night you have to charge it, and daytime only if it is excessive thing. And if you go for electric vehicles, but if you go for the solar vehicle, again charging is a major issue because when you park somewhere under the some shadow or shade, then it will not charge. So therefore, the main problem is it has to be always under the sunlight. And in urban areas, it's very difficult to keep always in under sunlight because of the various issues. So this is one of the reasons. And again, the charging and loading, because it should be matched to the loading conditions. So in Indian context, of course, we can, if it is limitedly loaded, like 1-2 persons, it's okay. But if you go more than higher number, then load, obviously there will be a performance drop. And third one is our infrastructures are not very. See, we are generally designed for the flat and good roads, but most of the time, you know that our Indian roads are not that very conducive for this. So the another problem is that. So the first problem is charging, recharging. Second problem is the infrastructural problems, and of course the operational means how to keep them whether under sun or out of the sun. Our infrastructure is for roads. These are the major challenges while developing these systems.
One last question, sir. Harshvardhan Reddy, can you please, sir?
Sir, good morning, sir. I am Harshvardhan Reddy from Sri Vidyanik Engineering College, Tirupati. I'm doing as assistant professor in Department of Mechanical Engineering. This is the second time I'm attending your lecture, sir. I have attended first time in J2 Anantapur. That is conducted by Hemchandra Reddy, sir. Sir, actually in India, as per MNRE is saying that comparatively solar thermal power generation is very lower compared to solar, the PV panel power generation, photovoltaic power generation, sir. What are the major challenges in the solar thermal power generation, sir, so far?
Major challenges in energy storage.
Yes, sir.
Because challenge is there, advantage is also there. Because then the size of the system. See, generally, if you go for PV plants, you can go for even very modular sizes. Even you can go for one family rooftop system. You have seen in the worst case, you can you have seen that the smallest one could be in your calculator. See, calculator is a solar cell. But we cannot use a thermal power plant to run the calculator. So therefore, generally solar thermal power plants are for bigger sizes. And when you go for bigger sizes, large scale operations, then the energy storage is also important, large scale, and the operating conditions are also very important. These are challenges, but advantages, we can even make it to operate 24 hours with lower cost when we go for that scale of operation.
Overall, what is the cost effective, sir, compared to PV power generation and solar thermal power generation, sir?
Solar thermal, see, PV is, if you see PV, it's more of a grid connected. Nowadays, what happens is, why we are going for PV in larger extent, because they are directly connected to the grid. Okay.
Yeah, off-grid applications.
Yes.
On-grid.
So that this energy is simply dumped into the or injected into the grid, so that grid will take care of the problems. And these solar panels are highly sensitive to the input condition. For example, I have seen that there are large solar parks which can produce two. So you have seen, I think.
Yes, sir. Anantapur.
No, Anantapur is there, Karnool is there, but now our Prime Minister is going to inaugurate, I think, India's largest solar park in Madhya Pradesh in this week. That is about 750 megawatt plant. So in such megawatt plant, what happens is it's highly sensitive to the solar condition. Suppose all of a sudden there is a cloud cover, then it will become zero output. Okay. Therefore, it's really important to predict how the operation is there. That is why we are also working on real-time operation of these systems, mainly using I don't know, most of your mechanical, but there is a lot of scope for this artificial intelligence, intelligence and machine learning for operating renewable energy plants. Okay, so because if when the cloud cover comes, we have to predict 15 minutes before the generation, like that, and the same thing can be given to the operator for grid connection. Whereas the thermal power plants can be even standalone and can work 24 hours with energy storage. That is an advantage.
Sir, I have visited NTPC power plant, solar power plant. They are saying also same challenge. That means suddenly cloud covers. There may be a balancing of connecting of voltage imbalance of connecting to the grid, step up, step down challenges they are facing. That it will come solution for this, then it will be a very effective. They are saying so.
Correct. And in Anantapur also you have that mega engineering solar thermal power plant.
Yeah, yes, sir. Yes, sir.
That's a very massive plant.
Yes. Thank you, sir.
Sir, namaste, sir. This is Adi Narayana, HOD Mechanical Host College, sir, MVGR College.
Namaskaram.
Sir, excellent presentation, sir. First of all, I would like to tell you that this is an excellent presentation and it comprehensively covered the usage of solar energy for mobility. So my question to you is, sir, is there any possibility of our students or faculty using your facility for research or doing project works?
Yeah, I think that is possible. We earlier also, many students, they come and look at, but in principle it is possible, and I also generally encourage, but now you know what is the present situation.
Sir, can you please suggest a few areas of research in this solar energy, sir, for students or faculty?
Areas of research for what? For the teachers or for the students?
For the teachers, solar energy, in the direction of solar energy.
Therefore, I think these most of the participants and teachers are from mechanical engineering. Okay. So therefore, as I mentioned, that there are two types of solar systems. One is direct converting into electricity, which we call photovoltaics. Generally, we have very limited scope, being a mechanical engineer, limited scope for solar panels, mainly material side. Some options are there, nanomaterials and so on. But otherwise, the panel production, we are panel development, there will be limited scope. But whereas the system level level problems we can solve. Like we can come up with a tracking system, or we can make it operational, like MPPT converters and how to connect them to the loads and all these. This is one of the options for PV side. But whereas thermal side, mechanical engineers have a tremendous role to play, and all concentrating collectors, hot water systems. Desalination is one of the in Chennai. We are facing an acute shortage of water, and sea water is converted into potable water with massive desalination plants located on the coast. Like we have about some 200 mld liter, 100 million liters per day plants are operation. They are mainly based on reverse osmosis systems. But nowadays they consume a lot of energy. So that energy, if you produce by fossil fuels, you have a problem. So therefore, if you produce this potable water through solar systems with solar energy, obviously it will become an attractive options. So these are some of the areas, like, solar desalination is one of the areas, solar collector developments is one of the areas, and process heat applications, like using solar energy for pharmaceutical industries, textile industries, and sugar industries, sugar cogeneration. We are working one of the recent projects on jaggery. Jaggery industry is one of the important industry where a lot of bagasse is used, and a lot of uncomfortable, unhygienic environment is prevailing. So therefore, if you develop a solar system for such applications, is also one of the research areas, and mainly dairy industries. Dairy also requires this milk pasteurization, cooling, heating is another problem. So their solar energy integration is mainly thermal integration is very important. So these are the areas one can work on, both power generation, process heat, and applications. Applications are very important. So these are some of the research areas one can think of for future.
Thank you, sir. Thank you very much for your time with all of us.
So, thank you, sir. Thank you very much for your kind acceptance to deliver the lecture in our STTP program, sir. So we have a very good time with you, sir. Thank you, sir. Thank you once again.
Yeah, thank you very much, and all the best for the rest of the program.
Thank you, sir. Thank you, sir.
Thank you.
So next we have next session will be Mr. G. Nichar, R&D engineer from Mercedes-Benz. So he will deliver the lecture. I request Kanamnadu sir to take over.
Srinivas sir is there. You can ask him.
Srinivas sir, can you please introduce Mr. G. Nichar to our audience, participants?
Sir, am I audible?
Audible, sir. You are audible, sir.
Good morning, Vananda. It is my privilege to introduce Nichal G. Nichal completed his BTech Mechanical Engineering in MVGR College of Engineering in 2012. Immediately, he started his career as graduate engineering trainee in AVTech Limited, which is the largest automotive transmission and powertrain components manufacturer in India, and reached the position as product manager within 3 years of his service. He was deployed in various departments like manufacturing, quality, and product design. He worked on architect of automated manual transmission based on MSG 5 series transmission. For this work, AVTech filed for patent in 2016. He also worked on design of AMT shifting components and selection of the shifter system. He joined in Mercedes-Benz Research and Development India as design engineer in 2015. He worked on design, development, and testing of torque tube housing for AMG GT, GTS, GT Roadster. It is the largest standalone component in Daimler cars. And he worked on optimization of differential for VAVE and performance improvement for AMG GT4. Also, he worked on failure investigation of differentials. So he worked on different vehicle platforms and subsystems. Some of them are Mercedes AMG electric and hybrid platforms, drivetrain concept, detailed design of drivetrain components, Mercedes AMG GTS torque tube, Mercedes AMG C63S, E63S, GT63S, which is related to differential, and some of the cars like Figo, Aspire, Fiesta, EcoSport manual transmission, Ashok Leyland DOST manual transmission and automated manual transmission, and briefly his experience in product design, which includes generation of drivetrain architecture, concept designing, re-engineering, modeling and detailing for powertrain sector, experience in field failure investigation of transmission and differential. Presently, he is working as senior design engineer at Mercedes-Benz Research and Development, India. Now, I request Nichal Ji to give his lecture on HEVs, their architecture and current scenario. Thank you.
Thank you, sir, for the introduction. Can everyone hear me?
Yes.
Yeah.
Yes. Okay. Yes. Okay. Just start the video. Okay. So, good morning, everyone. My name is Nichal. So, thanks, sir, for the introduction. So, we'll go into the PPT straight away. I guess there's a lot of lectures everyone has to attend. So, is my screen visible?
Yes, yes.
Yes,
okay.
Visible.
Okay. Okay. So here I'm going to give my opinion about electric vehicles and hybrid vehicles and what can be done in India. And also I'll talk very briefly about what is the international situation of the current electric vehicle and the hybrid vehicle portfolios of various manufacturers, right? So starting, I would say that all these, because I'm purely associated with an automotive industry, I would say that these opinions and comments, whatever I do in this presentation, are purely personal. So I collected a lot of data from various sources, including a lot of studies conducted by IIT Kanpur, from SIAM, which has a lot of data on market and all these things. And then again, SMEV, which has again data on electric vehicles and different various publications and all. So to start with, before we jump into the topic, I just thought, okay, to show you guys on what kind of vehicles I worked. Of course, Srinivas sir has already explained, but this will be a quick one. So it started with Hindustan Motors Ambassador, which is, I would say, the oldest car in India. So I was the last responsible engineer for the powertrain of the petrol powertrain of the Ambassador. Then I worked on the DOS. So I was responsible for the gearbox design or maintenance or product lifecycle management of the gearbox for this vehicle. Then we worked on, I worked on the powertrain integration for this vehicle called Mobius 2, which is a Kenyan vehicle. It's primarily for the African market. And also I worked a very brief amount of time on the 5-speed gearbox that's there, which goes into the Aspire, Figo, and EcoSport and all. And then in Mercedes, I started working on the high performance division, which is called the AMG. So AMG is a different company, which is a high performance division of Mercedes-Benz. So I started working on the high performance division and still continuing there. And so I worked on the AMG GT, which is the top line sports car when it was launched. So it was then. And recently I worked on the AMG GT63, which is the top end line of the current AMG GT lineup. So the top speed of the yellow car that you are seeing is around 310, 320 kilometers per hour. And this is approximately 330, 340 kilometers per hour. Okay, so let's go to the content. So these are the points that I'm going to discuss. So many of you might know that, okay, electric vehicles have been there. We have been talking, since quite some time on what is going to happen with electric vehicle and all. But I wanted the people to know that on what basis did we come to this situation, right? We all know that maybe all have been talking about electric vehicles, I would say probably since 2010, when Tesla almost came up with the Model S and they were claiming a lot of things. But there was hardly any activity before 2009, 2008 and all these things. There was some, but we are going to talk on how did things emerge from nothing and it grew exponentially. And within 15 to 20 years, the whole industry has taken a major shift, and on what basis. And then again, we'll talk about challenges of EVs in India. So when I say EVs, it is 2-wheeler, 4-wheeler, 3-wheeler, buses, trucks and all. And then what are the short-term and long-term goals that should be targeted in India, especially in India. Okay. So this is a very brief history of electric vehicles. So electric car is nothing new. So it's like it has got a history of almost 130, 125, 30 years, which was developed in London. So that was the powerhouse of the world at that point of time. But sooner or later in the 20th century, when we came up to 1910, 1912, when the automobile started gaining a lot of momentum with the IC engines, and the battery technology did not develop at all. It was like more on a stagnated. So then the IC engine technology just left, the electric vehicles in the dust, and they just instantly perished, I would say, in the span of 6 to 7 years. But again, so this was like we are talking about 1918, 1919 and all, and suddenly after 100 years, everyone is talking about it. So what happened in these 100 years? So this what I call is as the California effect. So of people who know California, it's a state in United States, and California is known for the world's most stringent pollution norms. So it has got a level. So for example, now we are in BS6. Europe, in some places, they are talking about Euro 7 and 7B and all these things. And so in similar terms, US is there, but California is always a step ahead, or it's more stringent when it comes to US or Europe or rest of the world. So that's why California. So basically, it's the most stringent pollution norm check in the world, and everyone targets to meet the California, regulations. So why is California so special, and why did things start at California? So this is a small map that you are seeing. So this is nothing but the Valley of Los Angeles. Los Angeles is a city in California. California is a state. So as you can see that there are a lot of mountains here. So you can see that there are Santa Monica Mountains, Santa Ana Mountains. So the whole city, which is approximately a population, I would say, of more than 2 million, it is covered by three sides, from the mountains, and one side is a sea. So what happens is when there is a breeze, okay, a lot of the whatever pollution is generated within this region is stuck in this one, because these pollutions are a little heavy and they can't go, above the clouds and all these things, and they just get stuck here. That's one of the reason why California is so heavily polluted. And because it was polluted, people wanted to, get some solutions for that. And then that's the reason some California took some decisions. The government of California took some decisions to go ahead and, solve the issues. So this is how it started. So in 1989, so there was a survey done by the county in the Los Angeles County. So out of 25% of the people within the age of 25 had respiratory diseases. So it's not something new that, I mean, we have been talking about Delhi pollution maybe for the last 10 years, but this is like 30 years before us. Then again, a year later, so there were 41 smog alerts. Smog is something what we now see in Delhi, but it's a stage one what was issued then in 90. So there were already red alarms ringing in the California, or especially in the Los Angeles region. So basically, as I told you, so it's a trapped valley. Um, of many of you might know how Vishakhapatnam is. So I would say that in India, when we take, from a geographical point of view, from a pollution point of view, I would say Vishakhapatnam is also kind of, a Los Angeles Valley, where, we are covered with mountains and one side is sea, and we have a lot of pollution. But fortunately, we are not so bad as, Los Angeles was 30 years ago. So what are the causes? So one, the industries, second, the automobile, and third is the port. So California port or the Los Angeles port is actually a very important port because it acts as a gateway to US on the western side. So whatever stuff comes from China and Japan, that generally comes through the Los Angeles ports. So what did the government do to reduce the whole issue of pollution? So one of the major issues what they found out at the port was the idling of ships. So when the ship is idling, or when a car is idling, when an automobile is idling, it runs at a very high level of brake specific fuel consumption. So basically the energy generation is low, but the fuel consumption with respect to that power output is high. So they thought that, okay, let me first attack this. So what did they do? They came up with a plug-in system. So whenever the ships are at the port, they get a chance to use the power source at the port from the local energy authority, and that's how they can, stop the engines from running. So lesser the idling or hardly no idling. No idling means no pollution. No pollution means better things for Los Angeles. And also they came up with the automated container movement. So these things were hardly there at that point of time. We are talking about 1980s and 1990s. So they came up with this also, which actually improved the loading and unloading time, and thus the ships need not stay in the port for a longer time, hence reducing the pollution, right? And then we talked about what about the pollution from cars, right? So we talked about industry, we talked about ports, and then we are talking about automobiles. So industries, anyhow, California also was one of the first counties to take a call on putting up the filters and all these things from the chimneys to reduce the pollution. But let's not go into that. So we are focusing on electric vehicles. So let's see what happens. And what about cars? So 28% of California's carbon emissions are from cars. So this is the latest, I would say, 2017 report. So in 1997, so this is where it all started, when people, when there was a lot of pollution and all these things. So in 97, they started, California law said that 2% of the newly sold vehicles should have zero emissions. When we say zero emissions, it cannot be a hybrid. It has to be either a hydrogen-based vehicle or it has to be a battery. When we say zero emissions is something, when a vehicle is running on road, it should not emit pollution on the road or in the garage. Okay, but the source of pollution can be somewhere else, because we are talking about a localized issue of pollution in the state. So that's the reason they are looking into this one. Okay. So citing this, General Motor came up with a new vehicle called EV1. So they had a very limited launch of 288 vehicles, and it was followed by Honda and Toyota. So this was somewhere in 1996 and all, because of course governments, when they put up a rule, they do discuss with all the automotive manufacturers, because the emissions, the loss, and the manufacturing and the whole economy goes hand in hand, right? So the EV1 had a range of 190 kilometers, which is very good at that point of time. But practically, that the claim done by the government or the automobile firms and all is relatively higher, because they are tested in a very standard setup. But the practical range was 130 kilometers, which is, I would say, fair enough at that point of time. But 6 years later, something happened. All of the 288 vehicles were pulled out from the road. So now what General Motor did here is that they leased the vehicle to the customers. They did not sell them to the customers. And what was the reason? I mean, that's a big story, but you can go to YouTube. There is you can just type the "Who Killed the Electric Car." I think there is some Spanish subtitles and all will be there. You can watch that video. It's a very, very interesting video. So what is the outcome is that it was alleged that, okay, so there is no, there's no report from the government saying that, okay, these things have been done, but everyone knows, but no one wants to talk about it. So it is alleged that the oil and the automotive companies, so because EV1 and the limited number of Honda and Toyotas, they were showing good amount of progress in the market, and people started accepting it. So they saw it as a threat, because by that point of time, all these major companies, you name them, they have invested billions and billions of dollars in terms of automotive development. You call it engine development, gearbox development, and all these things. And the moment, if there is any threat to them, it could be within their own company. They just don't want to see the millions and the billions go away. And that's what we are currently seeing now. Okay. So that's what they say, that it's because of the automotive and the oil companies, they formed a syndicate, and they took a decision that, okay, if these cars become a viral, then all our standard process and all our standard production and our sales and everything will go for a toss. So let's kill it. But again, there is no concrete evidence from that. So I would suggest everyone to have a look at this documentary. Right. So this was around in, so all the cars were approximately pulled back by 2003, 2004. So, and again in 2012, where we saw, so a decade later, California, the Tesla was launched in California again. And Tesla was there since this, during the same time, 2003, 2004, where they had the Roadster. But 2012 was the changing time when the Model S was launched, because this was the first car in the production variant which did not belong to any major automobile firm. And that actually caused a big, it threw a challenge right on face of every manufacturer in the world, saying that, see, I have done this, what have you got? Okay, so now when we talk about electric vehicles, there are different types of markets that first we have to understand before going into our country on specific situation. So as of 2007, you can see the 5% of the cars in US were electric. And as I told you that California is a flag bearer for USA in terms of pollution and all these things. 50% of the cars, again, this is of 2017 data, were electric. Now, when we talk about Tesla, as you can see that last year, it captured only Model 3. We are not talking about the other variants. Say, for example, when you talk about different manufacturers, they have so many variants of cars, but Tesla has only one model. I mean, in that medium and small size segment, which is a Model 3. And that itself, only one model captured 23% of the market share. Okay. So for example, you can see the data here. I'll just show here. Okay, so Tesla sold approximately 154 or 155,000 units. Okay, and you can see that BMW 234 series 113, Mercedes 102, Audi 77,000. So it literally sold more than twice of what Audi sold. Then you have Lexus. So you can see how Tesla has dominated the market in last 8 years. Before 8 years, no one really cared about it, but after 8 years, it's the market leader. So that's how the volatility has been there in the market. So people talk about mobile phones, laptops, and all these things, but you have a clear example in front of you. I'll give you the reason. For 77 years, probably from 1930s to 2000, early 2000, General Motors was the largest automobile manufacturers in the world for 77 years. And since then, it has been nowhere close even to the competition. And just for another additional information, now Tesla is the world's most valuable automotive maker in the world. It has surpassed Toyota just a week ago. So that's how we can see that. So 8 years, hardly anyone talked about electric vehicle, hardly anyone knew about Tesla, and now everyone is benchmarking them. And we say about benchmarking, so for example, when you want to develop an electric car, you would say, okay, what is the range of Tesla? No one talks about, say, XYZ company. Everyone says that this is the guy whom I want to pick. So they have set up a pretty good benchmark there. Okay, so that's the situation of US, I would say Canada also. Okay, and then when we come back to Europe, okay, so here we have the Scandinavian countries again, which are the flag bearers for the electric vehicles. So again, last year data, so more than 50% of the cars, in fact, it was close to 60% of the cars in Norway were electric. Okay, but the volume is 45,000 only. Okay, but this is on the Q1 data. So pretty much Europe is not as much, or the rest of the countries have not caught with the Scandinavian countries, which is specifically Norway and Sweden and Denmark, but they're slowly, closing up the gap between the other countries. Okay, so next we have a major competition in the world, which is China. So last year, so here we talked about cars in US and Europe. Now here we are talking about vehicles. So only 5%. So here we are talking about Norway, more than 50% of cars. And here we are talking about China, where we have only less than 5% of vehicles. Vehicles include 2, 3, 4, everything. But you see the volume, it's 1.2 million. So it is like 10.2 lakhs. And here we are talking about 45,000, give or take, or say 50,000, including two-wheelers. So there is a huge amount of difference on how the market is in US. US is approximately, last year was 250,000 units for all of them. We have, say, 50,000 units in Norway, and then we are talking about 1.2 million units in China. So there is a huge difference. There are different types of requirements, and there's a different demand for the vehicles and all these things. And recently, you know that Tesla has set up its second gigafactory in China. Okay, it's only second facility after USA. Okay, now these, I would say, are more or less the current major offering in India. So we don't have much other portfolio apart from these major manufacturers. So you know that there are four-wheelers majorly from Tata and Mahindra. Of course, we have one or two here from Hyundai. We have it from MG and other manufacturers. But primarily, say, in terms of volume, we are talking about Mahindra and Tata. And three-wheelers, of course, Mahindra is there. We have Lohia and Ecoyan. So these are relatively smaller companies compared to Mahindra, but they still have their existence in the northern part of India. And then when it comes to two-wheeler, of course, for India, the flagship when we talk about two-wheeler flagship models, Ather comes first, which is kind of Apple or Tesla Motors of India. That's what people say. And then we have conventional companies like Hero, who also have a small chunk of market share. And then we have this Okinawa and Yo, which are, I would say, more or less, they call it Japanese and Chinese and Koreans and all, but I would say everything is more or less from China. Okay, now, so we have talked about cars, we have talked about very bit of two-wheelers, but do we really know who exactly the culprit is? So this is the study based on IIT Kharagpur on Delhi. So you can see that one of the major output or pollution contributors are NOx emissions and carbon dioxide or COX emissions, as well as particulate matter. Now you see in the NOx contribution, 68% of the vehicular NOx pollution is contributed by mass transportation vehicles. So when I say mass transportation vehicle, you have buses, which is 27%. Okay, then you have trucks, which is 21, and then we have light commercial vehicles, something like those. You know, we have Tata Ace and all these things which transports people. But when you see cars and two-wheelers, it's like less, it's close to 30%. But when you talk about imparting pollution norms, we always target the cars first. The reason, these studies say that are we focusing on the right contributor? Why aren't we focusing too much on buses and trucks, which are causing, say, more than approximately 70% or more than 2/3 of the pollution? Why are we targeting only the 17% market? I mean, we still have to get some answers for that. Okay, and then we are talking about PM 2.5. So this is what causes a big issue every year in Delhi, the particulate matter. And you can see that 47% of the particulate matter is contributed by trucks. And then you can see that the next major guy who is contributing are the two-wheelers. And you see, when you combine both of them, they're approximately 80% of the time. But again, who does everyone target? We are talking about cars. Generally, car manufacturers are the first guy who are targeted. And then we are seeing that it's contributing only 10%. So this has to let the minds thinking that, is this the right direction where we want to head to? Is this where we want to see in 2030, 2040, 2050? Are we missing out some information, or why is the government behaving like this? Right? So we'll again discuss on each and every parameter, on each and every contributor, on who is doing what kind of stuff and what can be done. So let us start with the bus, because as we saw that the bus is one of the major contributors for NOx emissions, right? What can be done for buses, or what is being done? So there was a case study done by BMTC. BMTC is Bangalore's state road transportation. They do a lot of buses run in Bangalore. So they did a feasibility check for electric buses, and they bought buses from BYD. So this is a Chinese company, which is pretty much by far the largest electric bus manufacturer in the world. No one is even, I would say, 10% closer to what BYD is as of now in China. But of course, the bus is assembled in Hyderabad. So what happened is BMTC, after they did the trial run, they came up with a conclusion saying that they have saved approximately 50% of cost, or they have earned more than 50% of the cost based on the diesel counterpart. So when we are talking about running, we'll go to the next slide when we'll have it. And then on this slide, we'll just see what is the next. So just a couple of weeks back, BMTC had called for tenders for 90 e-buses based on the results. And, they have bought a few more, they have done a few more feasibility study. And based on the result, they have ordered 90 more buses, which is scheduled to be delivered by end of this year or beginning of next year. So when we talk about buses, we cannot compare, a smaller bus to a bigger bus. We have to compare apple to apple. So what you can see here is pretty much the same that is being done. I would say one of the key things, as you can see here, is the seating capacity. Of course, this is a CNG bus. We do not have a bigger number for comparison, but you can see that almost pretty much every bus is having the same seating comparison. Everything is more or less same length, same width, blah blah blah, same weight. But you can see the cost. You can see that the last one is the electric bus, which is from the BYD K9 series, the one which is tested in Bangalore as well as in Delhi. So this costs approximately 2 to 3 times more than a conventional Volvo, which runs in, I would say, major of the cities. I mean, the B9, which runs inside the city, it's easily costs more than 2.5 to 3 times. Okay, but okay, so let's say that cost is not a major issue. Let us look into the fuel efficiency and the other things. So you can see that, so whenever we are measuring the fuel economy for vehicles, we talk generally about liter per kilometer, or generally it's in the common perspective, it's generally kilometer per liter. In India, it's just the opposite. We talk about how many liters do we need it for so and so kilometer, or 1 liter how many kilometers. So but this is the standard things, right? And here you see we have something called a kilowatt hour. So instead of kilometers or something, we have kilowatt hours. So that's the way to measure the strength of the battery, I would say, or the efficiency of the battery in terms of running. Okay, because liters, say we have 5, 10, 15 liters, and battery capacity we also have 30 kilowatt hour, 100 kilowatt hour, 300 kilowatt hour and all. Okay, and you can see that this is the running cost. So what Volvo did is that it was comparing this Volvo, because both these buses are AC, both of them have more or less same height, width and all these things, and the same capacity, 32 and 31. So they compared a straight away number. So Volvo costs 23 kilometers per kilometer. That's the running cost, I would say. And then an electric bus costs is 10 rupees per kilometer. So that's definitely 50%, right? But there is a difference, of course, that Volvo can run for 484 kilometers and an electric bus can run only for 249 kilometers. 249 kilometers is as per standard Indian drive cycle. Okay, but of course, when we say 249, I generally have a standard calculation based on the database that I have prepared on different vehicles. So whenever I say that a manufacturer has claimed X number of kilometers per liter, then I just multiply it with 0.7, which more or less gives me the realistic range. So when you multiply this, I would say it would be maybe 75 less, so which is 150 to 160 kilometers that we are talking about, the actual range. Okay, and of course there is hardly any downtime for a Volvo bus, but every day you have to charge this for 3 to 6 hours by default to run it for the next day. This is not an issue because every night the buses are anyhow in the depots, and you can always charge it. Okay, next thing is that, of course, powers, we are talking about kilowatts and we have HP comparison. So I would say that's the reason now people are slowly looking into the electric vehicles. First of all, because of the running cost. Till now everyone had a range anxiety, which has been addressed by BYD, but again, all these are test results, the initial tests and all. We don't have a very huge data set to say yes, this is going to work. But this works in China. BYD has been very successful in China, and I'm sure that Indian traffic is kind of in more or less, I would say, like China. So let us say that it might, it has a very good possibility to, to have a success in India also. And you can see that we have, I forgot to mention that we have a lithium-ion battery, okay, which has a total, battery capacity of 300 kilowatt. So when you divide this by this, you should get this. So I would say more or less that's how it works. But again, this is not a realistic number. So now we know that this might work, might not work, and it is costing us a bomb of 3 crore per vehicle. And normally, not every bus in India is or at least in Bangalore is a Volvo. I would say majority of the buses are in the range of this 30 to 40 lakhs, not more than that. So is the government ready to spend 10 times more than a standard bus just to save some, just to reduce the pollution? That is one question. And the second most important thing is, so let us assume that the government wants to do it. Okay, they said, okay, there's too much of pollution, let me put up money. But do we have that amount of money to buy, say, 10 buses for 30 crores and get the money back? That's a big challenge. So that's the reason then there is something called bridging the gap. That's what we are going to look slowly in the PPT. So there is something called opportunity charging. So this is something new that has been developed recently in Europe for the last few years. So this is how it looks and how it works. Okay, pardon me for that. So this is the bus. Okay, the bus will have a pantograph. pantograph is nothing but the electric vehicle or the electric trains that you see, the one that is, you know, above the head. Okay. And then we have this black one, which is the charging station. And then we have civil works, or we need a backup place where we convert all this electricity into volts and the kilowatt amperes and all these things that we require. Okay. So I'll just quickly play a short video. I know that there will be a lag, but please bear with me. It's a relatively simpler video. Maybe you can just see. Okay, so this is the bus. So you can see that on top of it, we have the pantograph, which is tucked into the bus. Okay. And as the bus comes closer to the bus stop, okay, so now you can see. Okay, so this is the charging station that we are talking about. Okay, so this is, everything is electronically controlled, and the charging station goes into this port. And this port, what does it do exactly is that it emits a burst of power in terms of course, in kilowatts. Okay, and that charges the battery. So this is a technology that is still being developed, of course. And I have actually seen this technology when I was in Netherlands, in Eindhoven. And what happens is, exactly at this point of time, is that every bus stops at a stop for say 15 or 20 seconds or something like that. So the goal is to charge the bus in that 15 or 20 seconds. So as you can see here, that there's the second type of charging port, which is beneath the bus, not above the bus. Okay. And again, everything is electronically controlled. So what happens is that these 15 seconds of time plays a major role for charging the bus. So we previously talked about, you know, the BYD bus, which has a range of 250 kilometers, but this bus has a smaller battery. We are not talking about 250 kilometers. We are talking about say 15 kilometers, 5 kilometers, 10 kilometers. So what happens is, one of the major weights in the buses or any vehicle, in an electric vehicle, when I say, is a battery pack. Okay. And here, because we are using the opportunity charging, it's pretty simple, the term which says that opportunity charging. So whenever we have the opportunity to charge the vehicle, we are charging it. The term is as simple as that. Okay. So what happens is, the bus leaves the bus depot, okay, with a full charge. Okay. It has a relatively smaller battery. Okay. Say instead of 300 kilowatt hour, say it will have say 40 or 30 kilowatt hours. Okay. And this 30 kilowatt hours is good enough for the vehicle to go for 15 to 18 kilometers. Okay. So what happens is, say there is a bus stop every 5 kilometers. So every 5 kilometers, the bus will stop at the bus station, and it will have this. So by the time people get in and people get out, for 15 seconds, the vehicle will be charged. So I'll tell you a very quick thing. So for example, when the bus leaves the depot, it has 100% charge. It reaches the first bus charging station. Okay, say which is at a larger distance. Then say the charging is at 90%. The moment it reaches this stop here, okay, it gets charged for 15 to 20 seconds, which will bump up its charging maybe by 2% or 3%, not more than that. So it will be 92. It goes to the next station, say it is say 85, 88. You add another 2 in this 15 seconds, you know, 2% of battery is charged, it goes up to 90. So it's always this plus minus plus minus plus minus plus minus, and by the end of the day, okay, you are still left with enough amount of battery to go back to your to the depot. So that's how this opportunity charging works. And one of the advantages of this opportunity charging is that you have a smaller battery pack. The smaller battery pack, that means the lesser the weight of the vehicle. Lesser the weight of the vehicle, that means lesser energy losses. So for example, the energy losses that we are talking about, the BYD buses, will be definitely more than a standard bus which has an opportunity charging, because it's not so heavy. We just need a pantograph, we need an inverter and all, and that's all we are done. Okay. So the reason why should we look into opportunity charging is, this is a standard, I would say more or less a standard chart for a battery, okay, which is a charging cycle, I would say. But this is not again a hardcore one. So you can see that, and this is applicable to majority of the batteries. So you can see that within 1 hour of time. So here we have a graph for 3 hours, which says that in 3 hours I have 100% of battery, right? So this is the black graph that we should be looking at. Okay. And you see that within 1 hour, so which is 1/3 of the time, you see that approximately 80% of the battery is charged. And we need the 2/3 of the time, or 60% of the time, just to charge this rest 20%. So this is what we have to take the advantage. So this is what opportunity charging takes the advantage. So it takes bursts amount of time and it charges very quickly. Okay, and then now we are talking about multiple chargings throughout the day. Okay, so people might think that, okay, now instead of charging, it's like your mobile phone, so you're charging maybe once a day, and now in this opportunity charging situation, you're charging 20 or 30 times or maybe even 100 times a day. But isn't there an issue? We'll look into this. So what are the pros actually of the opportunity charging? So thing is that, as I told you, in Netherlands, in Geneva, in Switzerland, and in Luxembourg, it's already proven, it's running. As I told you, I have already been in Eindhoven, Netherlands. You don't even feel that the bus is stopping or doing an extra time just for charging the vehicle. You don't even get to feel that, right? So it's already proven technology. It has a lower downtime. Okay, because for example, if for some case, okay, the bus has an issue with the charging system, or if there is some issue with the battery draining quickly, the BYD buses or the pure electric buses without opportunity charging, they have more chance for lower downtime than the current one, because here we are not having a bigger battery, we are just taking power in bursts in frequent amount of time. So all the municipality or the guys who are taking care has to make sure that these stations are not down. Okay, one more advantage of opportunity charging is the battery life. Okay, so I have a very quick snap here, so you can see that when you're doing an opportunity charging, so when for example, when your battery is more or less in this range, as long as not going, so even when you see the manufacturers for your mobile phone, they say that try not to reduce the battery less than 20%, and then you do the charging. That's not generally recommended. It's purely because of this one. Okay, so when you do a charging in a very sweet spot, okay, your battery life has a tendency to have a better life approximately by 5 times. Okay, and of course, if you take this BYD bus, it leaves at 100% in the morning, it comes back maybe at 5% in the evening, and that will lead to a shorter lifespan of the battery. And we should all remember that battery is one of the most important component in terms of pricing for the vehicle, for an electric vehicle. So for example, if an opportunity battery, first of all, we have say 1/5 of the battery, okay, and it has got a better charging life. The second thing is that we have a regular electric bus which has a very huge battery and has shorter life. So what happens is, for example, if I want to change this battery, okay, I might change it in 5 years, and that too, this battery might cost me, now say for example, if this has 50 kilowatt of battery, okay, instead of the standard bus which has 300, so 50 kilowatt, I'll use it for 5 years. Okay, but this 300 kilowatt battery, it will definitely not last for 5 years, because we know that it has a shorter life. It might come for 1.5, 2 years. This is just a number for comparison. It's not really in 1.5 year, just a number for comparison for opportunity charging. So what will happen is that we have to pay for 300 kilowatt hours. Okay, say now the market price is $100. I would say give or take $100 per kilowatt hour of battery. So 50 into 100 is $5,000 would be the $500 would be the oh no, sorry, $5,000 would be the price of this battery, 50 kilowatt hours. Okay, but when you look at the electric bus, that has got 300 kilowatt hours. So we are talking about a very huge amount, okay, which is easily 5 times the amount of this one, because the battery is 5 times and it has a shorter life. So more or less, when you put everything put together, okay, this should cost you cheaper. But of course, this has the cons also. So it has got a high infrastructure cost. So when you compare it to a standard electric bus, you need the extra high power lines and all these things only at one spot, okay, which is the depot. But that is not the case here. So you need to have this this setup for each and every bus stops. I would say in Bangalore, we have easily more than 150, say 200 bus stops. So we need to put, assuming that we want to do everything, opportunity charging, we are talking about electrifying 200 bus stops. Okay, so there is a huge amount of investment that has to go into if we want this kind of model to work. And ideally, that is not the best case for India, because because of you can talk about the currency value and all these things, but in all terms, it's not the best investment, I would say. Okay, so now what is the proposal? Now we talked about opportunity charging, which is good, but it is expensive. But what can we do? So I came up with a proposal that why not give us a try for the BRTS line, bus rapid transportation system, which is there in, I would say, there are approximately 24 cities. Yes, so there are 24 cities which has BRTS lines in India, and 6 out of these 24 cities have more than 100 kilometers of network. So you can see Delhi Delhi is there with 115, Indore has 126, Bhopal has 186, and Tiruchirappalli has 112. So what can we do is, one thing, when we talk about opportunity charging, it is relatively risky in standard roads, especially when we have huge vehicles in India, especially coming into the smaller roads. It might damage all these charging stations. But when you have a BRTS, you know that these bigger vehicles will not come. So these lines are dedicated only for the buses, and they can actually use this kind of, the opportunity charging for the buses in the BRTS line. So this is one kind of proposal that can be actually worked out in India. Okay, if not exactly opportunity charging, we will talk something in the next slides coming about the trucks, and I feel that that technology can be clubbed up with the BRTS lines for India, which is this one. Okay, so we talked about buses. Okay, now let's come to the trucks. So trucks, in my opinion, would be the last resort of electrifying the vehicles. Of course, we have trucks from Nikola and Tesla, but we have to still see the commercial implementation of it, especially in India, where we have huge long distances to be traveled at a regular distances, and of course price is one of the most important things we have to see. But assume that we want to use electric trucks. The only last resort for having electric trucks would be, I would say, as of now, would be electrification of e-highways, or I would say e-highways. So you can see it here. So this is Sweden. Scania is a Swedish company, of course. So they came up with a 2-kilometer line. So this is just like a railway track, I would say, but the trucks are running on the highway. That's all. That's the only difference. So they have rubber wheels instead of tracks, and they run it on highway. So these are nothing but these are kind of diesel electric vehicles. So what happens is that you can use this pantograph, which is more or less it's the same for the opportunity station. Okay, and these lines are like your regular electric lines for the railways. Okay, so as long as you're in highway, you can run with the electric line, and the moment you leave the highway and you want to go into the city, you can run it on either in electric mode or a diesel mode. Okay, so this is the exact thing that I was talking about, what can be done in India. So we have BRTS lines which are specific for buses. Okay, and this kind of infrastructure will not be heavy. So if we have kind of a diesel electric hybrid, say having a smaller diesel motor, so as long as the buses are running in the BRTS line, they can use these electric ones. And once only if there are, because of the congested places in India, because once you get out of this main electrification line, maybe into the city center or something, at that small distances, they can still use the regular diesel engine ones if they want, or they can have a battery charger, just like the opportunity charging, and they can use in the battery only. So this is one of the things that India can do, because in terms of implementation, in terms of practicality, in terms of cost. Okay, so now we talked about trucks. Okay, and we saw in the previous slides that trucks are also a major contributor for particulate matter emission. So there was a study conducted on India. So this is what I was talking, diesel electric hybrid, but we were talking about how can we reduce the pollution with electric trucks or with trucks through India. As of now, this is not possible straight away. We might have BS6, we might get BS7, but still that amount of, or maybe a lesser amount of pollution, but it still will persist in India. But there was a study conducted. So this is a map of Bangalore. I have a lot of data about Bangalore because I have been here for the last 8 years. So there is something that they have been planning for a very long time, something called a peripheral ring road. It's something like the ring road in Hyderabad, kind of. Okay, and what the study said that if the trucks are diverted, so because Bangalore is the border of Tamil Nadu and Karnataka, and it is kind of a way through to Andhra Pradesh also. So this city acts like a junction for all the major routes. Okay, and I would say that majority, or I would say some of the portion at least would be, bypassing only Bangalore. So they don't have any business inside Bangalore, but they just want to bypass it. Okay, so that's the reason they have come up with this peripheral ring road. And the study says that if the trucks are, diverted in the peripheral ring road, and if the ring road is used with full capacity, the pollution will reduce, okay, by 50%, which is caused purely by trucks. So previously we saw that trucks were contributing approximately 40% of particulate matters and all these things. And so 45%, 47% ka half is 23%. So of course it's not exactly relatable to Bangalore and Delhi's numbers, but let us take just to understand on a number point of view. So we can say that maybe 10% of NOx can be reduced and 23% of particulate matter can reduce if we have peripheral ring roads in bigger cities and we divert the trucks towards it. But this is just a number thing, okay? And this is just a study conducted by different research institutes. Okay, now, so we are done with buses and trucks. Let's go to two-wheelers. So when we are talking about, vehicles, cars, buses and trucks, we need to sometimes look at the numbers also. So till now, we have not seen any numbers of sales in India because buses have hardly existed, trucks don't exist. When I say buses and trucks, we are talking about electric ones. But we do have the two-wheelers and four-wheelers in the market. So what happened is last year, there was a sales, the total sale was 153,000 units, which is 1.53 lakh units of two-wheelers in India. It had a growth rate of 21% compared to the previous year. In 2018, I still have the number in my mind, it was only 54%, 58,000, something like that. Okay, so we have seen a good amount of growth rate in India. Okay, but the biggest question is, just like we were talking about Norway and China, Norway has more than 50% cars. I mean, the newer cars are electric, okay, but they contribute 45%, 45,000 only. Okay, meanwhile in China we are talking about 5%, but the number is 1.2 million. I'm talking about vehicles, right? So percentage is something which, or when we talk about a global scale, it cannot be on a comparative basis. We cannot say that Norway is better than China because Norway has 50%. Yes, Norway has 50%, but it has a lesser population, it has lesser sales. So we cannot, compare these two things, but definitely we can compare the counterparts. So for example, as I told you, 1.5 lakh vehicles in India, okay, but this accounted just approximately 1% of sales of the two-wheeler market, because in India last year approximately 11.2 million vehicles or two-wheelers were sold. 11.2 million is more than, I would say, 1.1 crore, and we are talking about 1.5 lakhs only. Okay, for example, I want to give you a comparison. Okay, so 1.5 lakhs is the total sale for the whole year. Meanwhile, Honda Activa, which is a scooter, sells more than 2.5 lakhs units per month. It's not a year, per month. Okay, so we can see that how huge is the difference in the electric two-wheeler market and the conventional IC engine market. Okay, so I prepared a rough numbers on how the market might look. Okay, if we go with different types of CAGR. So this is compound annual growth rate. So we see the growth rate for every year on how it goes. The standard growth rate of automobiles in India is, or across the globe, is approximately 6 to 7%. Okay, so as I told you, in 2018, you can see that we had the number of vehicles of two-wheelers were 55,000. Okay, and here we have increased it almost by 1 lakh, because last 2 years, last 3 years, the CAGR for the e-vehicles, two-wheelers in India was 54%, which is the highest ever recorded. Okay, so if we say that we have a similar trend going, say by 2030, we will have approximately 71 lakh vehicles. Okay, say let us go a little more conservative at 30%, then we'll have only 13 lakh vehicles instead of 17%. So you can see that the CAGR drop is only 20%. But you can see the difference in the volume that we are talking about. We are talking a good 58 lakhs odd in the difference, right? And then if we go with the conservative, much more conservative, which is a realistic situation, I would say a realistic situation would be somewhere between this and this. And if we go with the CAGR of 15%, then we are looking only at 3 lakh vehicles. But of course, as we are seeing that we are already in 2020, we are approximately 1.5 lakhs, which is almost the half. So we can say that maybe by 2030, if this trend continues of 20 to 30% of CAGR, we are looking at 12.8 lakh units per year. Okay, but in the similar way, our normal vehicles will also grow. the idealistic situation would be to achieve 10% of market by 2030. Okay, I mean, assuming that everything goes good. So now these are, I would say, one of the leaders in terms of sales, or these are the major offerings. Okay, first we have a Hero, which is an Indian company. Then we have Okinawa, right? So the ranges what they claim is 110, 170, 90. So Okinawa price is having one of the highest one along with Aether. Okay, but 90 and 110 might be realistic, but when it comes down to practical situation, it is like less than 70 kilometers per hour. And then you can also see that, okay, the top speeds Okinawa is as good as, again, the price is as good as the conventional scooters, but Hero lacks a lot. So this is something which I feel that Hero has to work on what things have to be done. Okay, and then charging time we are talking about. So Okinawa prices claims that for the price they have come up with a better technology, and they say that approximately 70% of the battery, which is I would say, which comes up to say 80 to 90 kilometers or 100 kilometers of range, can be charged within 1 hour. Okay, so these are the major offerings. Okay, and this is the current situation. More than 95% of electric vehicles, okay, are low speed electric vehicles. So this is what we are talking about. Okay, so this is kind of that thing. It's not exactly. So low speed electric vehicles, okay, have less than 25 kilometers per hour, okay, that do not require registration and license. That's the reason that is not even captured in this number. Okay, because SIAM does not keep a track of how many vehicles of of these vehicles, because they don't require registration. Unless until you don't have the registration and the companies don't release the data, you never know. Okay, and okay, so now what is happening is there is a new way to propel. So someone has found out that, okay, if I'm going this conventional way, okay, I will be still stuck at less than 1% of total two-wheeler market in India sales. So let me try something new. So this is something, as I was talking about, Aether. So these guys are termed as Tesla of India. Okay, now what do these guys do? How are these guys, separate from this Okinawa and Hero and the other manufacturers? So we are talking about the S450. Okay, so yeah, hello. I hope you guys can hear me.
Yes, yes.
Okay, yeah. So as you can see that we have the Aether 450S, okay, where they claim that it is 107 kilometers as per the charging or the testing cycle, but they only came and said that no, it's actually practically 75 kilometers per hour. The top speed is 80, which is fair enough, and they claim that 1 hour of charging will take you to 60 kilometers of range. So when you see the charging of this one, you can again compare to the graph that I've shown you in the opportunity charging, that 80% of the charge is done within the first few hours or 1 hour. So because the battery is smaller here, it is taking 1 hour. But if you take bigger batteries for cars and for trucks and all, it will take a little more time, but the relation still remains the same. Okay, and now what things did they do separate? Of course, they have very futuristic styling, and they also have a 7-inch touchscreen, which has plenty of data and maps. So you can just navigate through all these things. You need not have a phone and all these things. Okay, and they have their own charging station. So in Bangalore, they have come up with a lot of charging points, as you can see. So they have targeted, I would say, 3 charging points, if I'm not wrong, for every 10 square kilometers or something like that. So these are the areas where they have already have the charging points, which means that you need not charge it just at home. Maybe when you go to a mall or when you go to a public place, if you find a Aether charging, you can just charge it. Of course, you have to pay some money. For the first year, I think it is free, but for the next of the years, it is directly linked to your bank account or your card and all. So you just have to pay by charging it in the Aether grid. So now you see how these guys are projecting. So they have come up with a same technology, a similar technology like Okinawa, okay, but they have made it more consumer, I would say, approachable. So they have something like a touchscreen, with the color TFT, which no one has in the market. Okay, and one of the most important thing is that they are not just selling a bike, they are selling an ecosystem. So they are telling that, okay, you buy a scooter from me for the first 1 year, you're charging, if you are doing at my Aether grid, which is in these points in the city, it is free for you. After that, you have to pay. So technically, when you play with the consumer's brain, okay, saying that, okay, so the moment we start about offers or something, this is a very good offer, I would say. So immediately we'll start thinking, okay, maybe per year I might save 20,000 rupees on fuel because I travel so many kilometers. And on top of this, even the major IT firms, they have charging docks for vehicles. Ather has done that also recently. So they're not just selling a vehicle saying that, okay, once you buy the vehicle, you just come to me for service. Apart from that, you and I don't have much things to talk about. But that's not Ather is doing. Ather is trying to integrate into the customer and say that, hey, if you have an issue, okay, you can go here, you can do this, you can do that, and we are there to support you. So that's how, you know, things change, and that's a new way, as I told you, to propel, you know, e-two-wheeler vehicles. Okay, now coming to the three-wheeler one. So here you can see that there is a three-wheeler flood. The reason I'm talking is very similar. So you might not have seen any three-wheelers much in the market, okay, but have you ever seen e-rickshaws? If you're especially in South India, I don't think so. You must have seen any, or if you have seen, there must be have been very few. But if you go to North Indian, especially in Delhi, in NCR region, there are already approximately 17.5 lakh vehicles on the Indian roads, and majority of the share is from Delhi only. So on an average, 11,000 units are being added up. Okay, so we are talking about a number that is constantly increasing. Okay, but this three-wheeler flood, so flood sometimes for few people, I don't know, but it may be good, but for few people it is really bad. For everything, you know, that is introduced in the market at a very fast rate, especially when we are talking about e-rickshaws, okay, everything comes with the pros and cons. So let's first look at the pros. So one thing is that it is eco-friendly. Okay, second thing that it is maintenance free. So now you should understand the majority of these 17.5 lakh vehicles that you're looking at is from China. Recently, it was only very recent that Lohia, Ecoyan and Mahindra started manufacturing, but still I would say more than 95% of these 17.5 lakh or 18 lakh vehicles are from directly imported from China, or if not directly imported, they're just, you know, assembled in India. So what is one good thing is that you don't have too many moving parts. So basically you don't have much maintenance. Okay, it is eco-friendly. So this is what Delhi guys would be looking for, saying because they suffer a lot with pollution issues. It has a better return on investment. ROI is return on investment. So it's not too expensive to buy, and you get, you know, easier money from that. Okay, and it has a better passenger density. So generally in autos, when you say, for example, in Bangalore, you have a restriction of 3 people and all, but these vehicles, they are designed in such a way that you can carry up to 5 to 6 people also. Okay, so it has got a better passenger density. Now, what are the cons? The cons are that it is a short distance route, so you cannot have it for a longer distance compared to a regular auto. But when we are talking about the last mile connectivity, short distances are still okay, I would say. Okay, and then we are talking about battery issues. Now these batteries are nothing but your standard, you know, alkali batteries. Okay, these are not lithium ions, because a rickshaw wala, he cannot afford a lithium ion, you know, propelled car. So these are standard lead acid batteries. Okay, and the moment we are talking about the conventional battery, which has a lot of charging and discharging and all these things, we definitely have some issues with the batteries. Okay, so there have been some instances of the batteries exploding, consumers being hurt, or the batteries not charging for a longer duration and all these things. Okay, but when we are talking about a society, one of the biggest issues is not, I mean, of course, pollution is an issue, but from the government point of view, there is no regulation on these vehicles. So if you have seen in the two-wheeler slide, I've talked about 95% of the vehicles are less than 25 kilometers per hour. But there is a government rule for homologation, which means for certifying the vehicles, that if your vehicle is less than 25 kilometers per hour for electric vehicles, you don't need any certification. That means there is no one actually to overlook and say that yes, this vehicle can ply on road, because that regulation has been there like that. Okay, so there is no control on the number of imports or anything on that. That's the reason we have seen the sudden flood of e-rickshaws, and that is the reason there are certain quality issues also. And because there is no regulation, there is no one to authenticate from the government saying that this vehicle is safe. There is no one to talk about it. That's the reason it is not safe also. So these are some issues with the regulation. So what can be done? So we are talking about, you know, deregulation. So we need to do we need to do regulation, and because of deregulation we have this population explosion. Okay, as I told you, Mahindra and Lohia have already launched their e-rickshaws. Now the government is actually they have, I'm not sure if they have implemented, but they have put up a draft saying that all the vehicles, even below 25 kilometers per hour, that is not naturally propelled. Naturally propelled in the sense we are talking about cycles which are human pedaled. Okay, so anything which is not human propelled, the rest of the stuff have to be regulated. So that's what they have brought it, because of this specific issue of e-rickshaws in India. Okay, now finally the four-wheeler market, which generally everyone talks about. Okay, so last year we had only 1650 units of sales. Okay, to compare this, say for example with say Suzuki or something, there is a model of Suzuki called Baleno. I hope most of you might know, and that itself sells close to 20,000 units a month. And here we are talking about 1650 units a year. And we just don't have one or two models, which were a case 4 years back. We have a good 6 to 7 models in India as of now. So even though manufacturers are trying to come into India and they want to, push the electric vehicles, people are still not so keen to buy in it. There are certain reasons, okay, and which means there are certain challenges. So what is the challenge? We will talk about each and every sector of challenges. So what does a consumer face a challenge? Consumer first thinks that I'm talking about a price. More than 90% of the vehicles that are sold in India are less than 10 lakh rupees. Okay, are less than 4-meter range and all these things. So the moment we are talking about sub 10 lakh rupees vehicles, I would say more than 60% of the electric vehicles, they fail to meet this criteria, less than 10 lakh rupee range. Okay, so consumer is left with hardly one or two models. Okay, and top of that, the consumer has a range anxiety. So till now, whatever cars we had, at least till the recent launch of Nexon, the previous cars like Tata Tigor or Berito and all, those cars had a range, only a practical range of 80 or 100 kilometers per hour. Oh, sorry, 100 kilometers per charge for a full charge. And that's really not even close to what a consumer wants. So certainly the sales speaks the number. Okay. And if a consumer wants to have a vehicle, an electric vehicle might be a second vehicle in India for consumer, but it will probably never be a primary vehicle, at least at this point of time. And then when we combine all these three things put together, we are talking about practicality. Okay, practicality also includes power shortages and all these things, which we'll talk about infrastructure capital. So then we are talking about commercial usage. Okay, so what happens is in India we have a lot of abuse of vehicles. Say for example, abuse in the sense of vehicle abuse. So say for example, you have a service cycle of 5,000 kilometers for servicing your vehicle. How many of Indians actually get the vehicle serviced at 5,000? It's very rare, because I worked on all this field failure issues which has been there. And when I go through these warranty issues and all these things, because I was responsible for a gearbox, I've seen that these guys have done probably maybe one service or two service in last 1 to 2 years or 3 years, where the company is recommending to get you serviced every 6 months to say 1 year, people are getting it serviced once in 2 years. So it's a customer problem, right? So it's a common trend in India. It's not just only passenger vehicles or something. It's a common trend. Okay, second thing is that infrastructure. So infrastructure, when we talk about charging dockets. It could be at home, it could be at public places and all these things. But slowly, to make it a commercial success, infrastructure lag has to be overcome. Next, we are talking about infrastructure capital. So we are talking about infrastructure lag, right? And then we have infrastructure capital. Capital is nothing but someone like, say for example, Tesla Motors. Tesla Motors said that I am going to set up my charging stations across US. That has more or less not happened with India. So there is no big investment from any kind of firm. Okay, they might have their own issues. Okay, but they say they don't believe that they believe that we can't put so much of investment in putting up the charging stations. So only when people start seeing charging stations, then only people will have more, I would say, more belief, saying that okay, I can see charging stations, that mean there might be electric vehicles, and then only slowly the confidence will increase. But that is not happening. Okay, as I said, hesitant private players. So everyone talks about government has to do this, government has to do that. But again, if you take Tesla as example, as I told, Tesla is a private player. He did it on his own. Okay, So then portfolio from manufacturers. So manufacturers say that there is no market, and of course the technology is slowly improving, but it is not still at the best place. As I was telling that the current rate of buying the battery in the world is more or less at $130 per kilowatt hour. In my opinion, to make it viable for India, it should be less than 80 kilowatt per hour. Then only cars can be economical in India. Then again, land acquisition, if you want to put up charging stations and all these things, land acquisition is the problem. But we can say that, okay, fuel stations are something like this, so we can ignore this. And then government push, which is we are going to talk about a later stage. Okay, so this is what has happened or is happening and or is going to happen or probably should happen in India. Okay, now we are talking about international situation. So we have talked about Tesla. So there is another company called Rimac Automobili. So this is a Czech Republic company, if I'm not wrong. Oh no, it's a Croatian company. Okay, so these guys have come up with the high performance cars, and they have a very good electric vehicle technology. And then we have Nikola. They themselves call themselves as competitors of Tesla. They are based in US. Okay, Pininfarina is actually not an automobile company per se. It is a design company which styles the cars. So these guys have styled Lamborghinis and Ferraris and all these things, but they have never manufactured a vehicle on their own. Say more or less a production vehicle they have never done. They did some prototypes, but they never did. Okay. And then we have Dyson. Dyson is nothing. This is a company which actually makes home appliances. It makes hair dryers. It makes vacuum cleaners. Even Dyson has come into the race for this electric vehicle situation. Okay, so we are talking about Tesla, which is, I would say, the benchmark. Rimac, Nikola, they have come from nowhere, but of course Rimac has proved. Nikola is yet to prove. Pininfarina has some relevancy to automobile, or a very good relevancy to automobile, but they don't have the relevancy to design a car for themselves. And Dyson, as I told you, is a home appliance manufacturer, and even such people are into the market. So previously that was never the case when you see. Okay, but now what are the situation? I'll explain you. Now Dyson is out of competition. It's very simple, because they have stepped into an unknown, absolute unknown territory. They thought that, okay, now electric vehicle battery, I can buy it from someone. Okay, I can design a car from maybe some third party and I can fit it. They thought it was something like a cakewalk, but that never happened. And Dyson recently pulled out from the car electric car race. Okay, and now we'll talk about some list of standard automobile companies. So we know about Jaguar has a I-Pace, which is the electric SUV, and of course, and Jaguar is owned by Tata Motors, right? Then we have Porsche and Mercedes. Now the reason I'm placing it like this is for a reason, is that now this Rimac is a Croatian company. Okay, so Mercedes, when they wanted to develop their first electric vehicles, okay, they had a MOU signed with Rimac. Okay, and they bought some shares with Rimac. Now then what happened is Porsche came into the picture. Porsche bought a bigger share in Rimac, and then Mercedes said, okay, I cannot have one supplier, this supplier, develop the same technology for Porsche and for Mercedes. And then Mercedes pulled out because Porsche had a bigger stake in Rimac. Now Rimac is now purely working for Porsche. Okay, so this is the international situation. Then we have Toyota and BMW. Everyone is kind of, I would say Toyota has their own technology. BMW will talk a bit. And of course, if you guys don't know, Pininfarina is owned by Mahindra. So Pininfarina has its own supercar, which is still under development. So you can see that now suddenly when you see this global list of competitors, you can see that there are actually 2 Indian manufacturers which have the technology, if not directly, but indirectly. Okay. And then we have General Motors, and of course Ford, and all these guys are there. They have been there with their electric vehicles for a long time. So you can see that. So this is one segment who are newcomers. This is the second segment, so in which they have their own technology or they are trying to poach others. Okay, then we have the third one. Now if you're not in the pure automobile domain, you might not know these guys. So these are guys are ZF is the biggest transmission supplier, I would say, more or less in the world, and all the BMW gearboxes and differentials are from ZF. Okay, Magna and Hofer Powertrain also, these companies they don't manufacture cars. Let me be very clear. They they supply only gearboxes, they supply engines, they supply differentials only to all the other manufacturers. Okay, sometimes Mercedes buys it from Magna, it could be that Toyota might buy it from Hofer. So these guys are nothing but these guys are going to play a major role in the upcoming segment. So the reason I'm telling is that each and every one of these are just 3 examples. There are at least 7 to 8 more companies who are developing their own electric vehicles or electric powertrain they are developing. When I'm talking about powertrain, we are talking about the unit that is going to drive the vehicle. We don't have an engine, we have a unit, e-motor, gearbox and all that is going to drive the vehicle. So these guys are developing that. Okay, which means that if someone, say if Toyota does not have any technology, Toyota can straight away go to ZF, it can go to Magna, it can say, okay, take $1 billion and give me a electric drive unit. Magna will say, okay, take it, simple. And suddenly from nowhere, Toyota is into, in competition with Mercedes, Porsche and everyone. So that's how volatile the situation has become. This was never the case before. For at least the first 120 years of automobile industry, only the major manufacturers had progressed. There was hardly any scope for smaller manufacturers to come. But now it's like a mobile market. Whoever has the best gets a market, as simple as that. Okay, so this is one major threat that the conventional automobile industries are looking at. Okay, second thing is Google, Facebook and Apple. So these guys, they are exactly not into automobile industry. Okay, but these guys have made their efforts to develop their own cars. Okay, but the real threat is not them developing their car. Okay, the real threat for the automobile industry or the standard bigger manufacturers, I would say, is that these guys have so much of cash that they can overnight buy a company like Rimac, or they can buy Tesla. Of course, this is now a public company, but they can buy other companies which are slowly progressing. So if Google says, okay, now I want to get into automobile sector, okay, it can pay maybe $20 billion to Rimac and it can buy the stake from Porsche, and now Google is suddenly in competition with the major automotive giants. So we are looking at so many cases. It can happen with Apple also. Apple can buy someone and they say that, okay, now I'm into automotive race. So it's like just like the mobile market. People think that, okay, automobile market is difficult to crack. Yes, it was till this point of time, but not anymore. You have money, the technology is available. If you can invest that money, if you can agree your supply to be bought, that's it. You are in the industry and you are in the front runner. Then it's not you are somewhere in the back, you are in the front runner. So how can we do this? So electric vehicles, we are talking about long-term gaps, but how can we bridge these gaps? So we have something called hybrids, which I'm sure everyone knows. So I'll go very quickly because I think we are running out of time. So we have 4 types of hybrids. Okay, so one is a P0 hybrid, which is nothing but a belt starter generator. So when we talk about start-stop mechanism and all these things, we use a P0 hybrid. So this is what you see in Mahindra and your Suzuki cars. So that is just the start-stop mechanism. Okay, it does not add anything. Then we have the ISG. Okay, ISG does the start-stop mechanism. Okay, and also it gives a very brief amount of power torque or torque during acceleration. That's where we call it mild hybrid. It's called a P1. Okay, and then we have P2 and P3. So these are full hybrids. Okay, where the e-motor, okay, is attached after the clutch here. So you can see that the e-motor is at the belt drive of the engine. Okay, so that is where it used for start stop. E-motor is before the clutch and the transmission. So this is just after the IC engine. So this is just going to, it's a very small pack. Okay, this is just going to assist in acceleration. So acceleration is where you use a good amount of fuel. So when your torque is added in acceleration, okay, that means you are saving some amount of fuel. And in full hybrids, these, what happens is, say for example, one axle is driven by the IC engine and gearbox, and the second thing can be run only by a e-motor. Okay, and the final thing is the range extender. So this is also full hybrid, and this is a typical construction of, I would say, an electric vehicle. Okay, so if you just have this on this axle, it's a pure electric vehicle. So here also, as you can see, that engine and gearbox and all this information, or that that torque and all, everything is added. This is exactly not the P4 construction, but this kind of close. Okay, and the drive is given, the torque of engine gearbox and the e-motor is added to the differential and it is given to the wheels. So you can see that by having the different types of hybrids, you can see that we can see some amount of increase in fuel efficiency, 14 to 16%. And for example, this P0 hybrid is not very expensive. It's actually very cheap. That's the reason it is there in Suzuki and Mahindra. And P3 and P4 are actually expensive. For example, when you take P4 is available in Volvo XC90. That Volvo XC90 costs 1.3 crores or something. That is very, very expensive. So P2 and P3 are something which are not, I would say, feasible for India in terms of volume, but definitely P0 and P1 can, where we can have even a mild amount of increase in fuel efficiency. Okay. So finally, we are talking about the push and its type. So we are talked about, okay, what these guys are doing, what those guys are doing, how things are looking like. But what is the push that we are talking about? We are talking about the government push. Now it's finally, we are talking about what can the government do. So the Chinese government has a rule, the Communist Party has a rule saying that for 2020 and above, okay, at least 12% of the sales of any manufacturer has to be either plug-in hybrid vehicle, PHEV, or an electric vehicle. Okay, that means only 88% of the cars can be only pure IC engines. Okay, so this is the push that Chinese government has. Okay, what does the Indian government have? Indian government have a FAME scheme. Now it is running in FAME 2, but we give this FAME scheme, or we do push for electric vehicles in terms of subsidy, which is say around 10,000 crores. Okay. So what happens is, every time, for example, if you're buying a Suzuki or something, or a Mahindra which has a micro hybrid, you will get some discount. Of course, they'll give you with the discounted price, but the government is actually giving you some incentive, for buying these hybrid vehicles. Okay, so that's the current situation. But what is the requirement? Okay, the requirement is that India has to, I mean, again, this is an opinion, that India has to put this opportunity charging. They have to reduce the prices of your infrastructure related to opportunity charging. Okay, and the BRTS lanes, the one which we talked about in the FAME scheme, and they have to reduce the potential infrastructure cost, which is the biggest issue for implementing this. Okay, and the second thing is that quota sales. So just like your Chinese government, okay, they can make it mandatory. Say for example, in two-wheelers, you might not make an electric vehicle mandatory, but they can come up with something like a switch on engine off button, which can be done mandatory. So this might not increase the fuel efficiency greatly, but it will reduce the pollution at traffic and all. So they can start with minor steps like this. Okay, and as I told you, so they have to make either plug-in hybrid. It can be a P0, P1, P3, P4, depends on manufacturers and their market, but they have to make it mandatory, just like China. So again, we cannot ask the Indian manufacturers suddenly, say from 2021 you start selling 10%. That is not feasible. You can start maybe with 1%, 2%. You have to give them time to develop their technology, and that's how it has to be done. Third thing is regulation. So because we have talked about the smaller vehicles less than 25 kilometers per hour, so this is already in situation or in motion, and we want regulation to be done for these things also. And especially now the Atmanirbhar Bharat has come into picture, so they're trying to push more of these electric vehicles and all these things to be manufactured in India. So yeah, so this is what I just wanted to show, that what can be done in India, what is the situation, and what are the proposals. Okay, now I am open for Q&A. I know a lot of data to churn, but yeah, so these short-term seminars, they are always like this.
Yeah, thank you very much, Nishal, for your in detail session on electric as well as hybrid electric vehicles and its situation in India as well as abroad. So now the session is open for questions. Dear participants, if you have any questions, please raise your hands. We'll unmute you so that you can ask the questions. Yeah. First, Dr. Venkatesh. Yeah, please unmute, sir, Dr. Venkatesh.
Yes, sir. Good afternoon, sir. Good afternoon. Hi.
Hello, sir.
It was a nice session. You have given a full blend of four-wheeler and two-wheeler and recent technology in global market. Thank you for sharing your thoughts. My question will be like, since this electrical vehicle scenario is now it is picking up in India,
Right.
Is there any chances for academicians to build a small lab setup kind of thing for a component wise? Is there any chances for kind of things, or is it not possible kind of?
Okay. So I would say that see, yes. Okay. You have another question?
No, fine.
Okay, yeah. So one thing is that when we talk about electric vehicle, okay. So I assume that you're talking only about the power unit, right? Power unit, which means the prime mover, which will be the motor and all these things, right? Hello?
Yes.
Okay. So in that case, I would say that this is just an adoption. Okay. We already have motors in industries. We are not talking about cars. So what I generally suggest people that first we have to look what is available in the market. Okay. Say for example, you want to set up a electric vehicle testing facility, say in your college for students. Fair enough. Do you have the setup, or do you have, suppliers giving you the technology? No. Okay. In that case, what I would suggest is to try to find what is the next best available in the market. We have been using motors. See, again, it's a motor even in an electric car. There is a motor even in your industries and all these things. So what we have to do is we have to find the nearest industry. Okay, it could be any propellant, it could be maybe generator industry, it could be anything which uses motors, but it has to be a similar type of motors. Okay. And if you see from an industry point of view, the infrastructure is already available. So if you want to buy a motor, okay, say from some industry of some other purpose, you will definitely get it. And that infrastructure is so much well available that you can take up that same infrastructure. Okay. But the most important thing is that you will not have the exact output what you're looking at, because to have an automobile type of output, you need to have an automobile type of setup. Okay. But what you can do is you can take this industrial setup which is already available, and it will be cheap, relatively cheaper. Okay. And what you can do is you can add your tweaks onto it. This is what I would suggest, and that would be the cheapest and the most reliable thing that you can, that is currently available in the market. It's pretty much possible. Okay. Yeah.
Okay. Next question is from Vinod Kumar.
Okay.
Hello.
Yes.
Hello. Can you hear me, sir?
Yes, I can hear you.
Very good afternoon, sir.
Good afternoon.
Your lecture is very excellent, sir.
Thank you.
Sir, what is the status of this lithium, metal air batteries right in the market, sir?
Currently, there is, I would say, there is no infiltration of any other battery in the market. Okay.
So that we can increase the speed as well as the range.
Right. I understand. See, there are 2 or 3 things we need to understand. First thing is that the technology has to be proven. Okay. Yes. Second thing is that it has to be commercially viable. Okay. Say, for example, lithium ion battery has been there in the market for 10-15 years, mobile batteries and everything, right? When we are saying lithium ion, I would say you go back to mobile batteries. So mobiles in India or across the globe have been there for good 20 years, right? So it is a proven technology. Lead acid batteries has been there for good 50-60 plus years. So that has been a very good standard industry. The moment when you're talking about, say, a new end technology, okay, it can be used, okay, but it can be used only, say, for prototypes. Okay. Say, for example, you have, and trust me that this battery, whatever you're talking, is first will not be available, okay, easily available. Second thing is that it is going to be very, very expensive. So probably, say, for example, if you are a student, okay, and if you're studying at a university and you get a funding, you might, take this technology assuming that someone is going to give, but trust me, no one is going to give you, because unless until these kind of technologies, right, which is going to change the future, that no one is going to give out easily for free, until unless they put it in their products and their products start selling and they have made good profits. And others have also started producing something like that. Till then they will not give it to the outsiders. Okay. But let me assume that you somehow get hold of that technology. The best thing what you can do is you can compare this technology and that technology. Okay, say for example, you're talking about some lithium air ion battery and all. So what you will do eventually is that you will put it in the same scooter which had a say lithium ion battery, and then you will do a test run, right? And then you will say that, okay, I have used say so and so battery, I have got 110 kilometers. I've used lithium ion battery, I got 60 kilometers. So 110 is better than 60. So this battery is better than the lithium ion battery. Okay, so this is the best output that you will be expecting, correct? But you should also understand that the guy who is giving you this battery has already proven it. And because he has proven it, that is the reason you are buying that battery. Okay. Got it? So only if you are going to do some kind of research on it and you want to tear apart the battery, you have some good chemistry labs in it, you have a lot of PhD guys around you, then it will make sense to get a proper output. You can get output. I'm not saying you can the best, but as I told you, the best output what you will have is this battery has given so and so mileage, this battery has given so and so mileage. That's the best output that you can give. Okay, so new technology, it is actually, and another thing is that it is risky also. For example, it might explode and all, you never know. Okay,
Next question from Piyush.
Yes.
Yeah, good afternoon, sir.
Good afternoon.
Sir, this stop technology, which is there in the Mercedes-Benz, it can be considered under P0 micro hybrid.
Yes, yes. The start-stop system is always a hybrid system. It's always a P0 system.
And next thing, that why we cannot have manual transmission with electric vehicles, plug-in electric vehicles? Why there is only CVT or automatic transmission option?
Okay. See, one thing is that the moment we are going into hybrid, okay,
yeah,
we have to be very clearly, we have to understand that the moment you are going to a superior technology, okay, no one wants to, do this extra work. That is first thing. I mean, when you look from a, consumer point of view, okay, for India, okay, we might think that, okay, driving a manual gearbox and all is fun. But
see, I can understand because I am associated with your brand.
Okay.
We are running a course, Adam course at our center. So I used to go at Pune for frequent trainings at MVGR. Okay. So you don't have manual transmission because of the
no,
cost.
we do have, we have, but in Germany, we don't have it in India.
Yeah, India
we have it in.
Means Indian market point of view, people here prefer manual transmission because of the cost. So if we put manual transmission in PHEVs, so don't you think that it will lead to reduction in cost?
No. See, I'll give you a very clear reason. The moment we are talking about plug-in hybrid vehicles, right? We are talking about say P3 and P4, right? That is an expensive affair. Okay. So when you're talking about from a consumer point of view, okay, say for example, if you want to go to an, say, let us talk about AMT. I have designed AMT. That was there in the profile, right? AMT or automated manual transmission, it's just an add-on to the regular manual transmission. It is just relatively lesser expensive. It's just 30,000 expensive, right? If you take a full automatic transmission, okay, say it will be 60 to 70,000 more expensive than the manual transmission. I'm talking
CVT and manual, 70,000.
Right, 70,000, right? Give or take. But when you're talking about a hybrid, okay, P3 hybrid is going to cost you 7 to 8 lakhs more than your regular car.
No, if it is a pure electric vehicle, then that from that point of view,
if it's
there is only a motor.
See, if there is a motor, okay, you need to have, I mean, I'm assuming that you have a high RPM, low torque motor, okay, then you need to have 2-speed gearbox. In that you can have, okay. But one of the USPs of electric vehicle, that also you should understand, okay, range is not the USP, range is a concern. Okay, but the USP of an electric vehicle is something, I would say, if you are selling an electric vehicle, you'll say that you have only accelerator and brake. You don't have a clutch pack. That's what
similar that we have in CVT or
exactly. So that is a USP. The moment you add again clutch pack, okay, and you have a gearbox, that can be done. It is pretty much possible. There is nothing to deny it. But the moment you put that, the customer, I mean, if there's a technical person like me, I would say, why would you do this? You don't need it first thing, because I'm paying 8 to 10 lakh rupees for a battery technology which is not proven. I'm putting a bet on you. Why do you want me to sell a manual gearbox? You put up a actuator which shifts the gearbox. So it is pretty much possible. Nothing is not, I mean, this is not, I would say it is not possible or something. But when you put it from a practical and, a market point of view, this is not going to succeed. This might succeed Okay, only probably when you have a very low end car, okay, and you want to reduce the cost and all, it is possible. Okay, but I don't see that it is actually a very good approach to go into it. But for a project, for a personal point of view, it can be done.
Next question from Abhiram.
Hello, sir. This is Abhiram, Assistant Professor from Mechanical Engineering Department, RVC, Bengaluru.
Yes, sir.
Sir, my question is, since in Bangalore, we don't have this BRTS facility, do you think having this charge the way the one that is used in Netherlands or something you told,
Yes,
is it possible
opportunity
in
charging.
Bangalore? Can we try to implement this, or is there a possibility to do this?
Right. See, the opportunity charging, okay, is specifically for places where we can't have this BRTS lanes and all these things. Okay, if we have the BRTS lanes, for example, I think now Bangalore, we have in outer ring road, they are putting up the lanes now, especially for buses. Okay,
Yes,
so
yes, yes.
so let us assume that it is not there. Okay, so the opportunity charging specifically is for this purpose. Okay, but as I told you that it is an expensive affair. Okay, I remember the statistics if I'm not wrong. Okay, see, we need to pump. Okay, so when this bus is charging, say for 15 seconds, right, we have to charge, yeah, this one. Okay, we have to charge, or the current that we are talking is 250 amperes. Okay, and the power we are talking is 600 kilowatts. That's a huge amount of energy at a very less amount of time. Okay, so infrastructure can be developed. Nothing is impossible when we are talking about this opportunity charging. Okay, but the infrastructure cost is way too high. That is where, we want the government to put, not just the bus, because in FAME scheme we are just talking about buses. Okay, there is no discount, or there is no subsidy for this infrastructure that needs to be developed. So the government has to come up with, or they have to put these kind of technologies also in FAME for it to be more economically viable. Only if it is economically viable. If I'm not wrong, the charging to set up this investment cost, it costs around 40,000 for less than a kilowatt hour. So when we are talking about say 600 kilowatts, so 40 into 600, we are talking about, I don't know, some 24 lakhs per station we are talking about. So we have, say, 200 bus stops. Okay, 200 bus stops into, say, 24 lakhs. So we are talking about, I would say, maybe 48 crores, good or give or take. So 48 crores is a very huge amount of investment initially, and then we have to maintain it. It is possible, but it's an expensive affair.
But
And again, the technology has to be available.
Correct. Now, whenever we are trying to go for these type of heavy voltage or current sources, we should also worry about the power supply to these stations, right?
Very good question. So this is one advantage, for the opportunity charging, because see, when you are, when we talk about the grid point of view, from the electricity grid point of view, okay, say if all the regular electric buses are charging at depot, okay, then what will happen is a huge amount of current is diverted only to one area. Okay, but when you have opportunity charging stations at different places, the power source is actually distributed. Okay, of course it is high intensity, it is very dangerous. Okay, but the construction can be done in such a way that it can be safe. Okay, see, unless until someone goes and put their hand into this pantograph area, it will not give a shock, because everything, it will be like our electrical wiring, everything will be within the ground. Okay, so I would say, from safe point of view, in India it might not be so safe that we are actually thinking. It is actually relatively risky, but with the proper design of these elements, I think that can be reduced, but it cannot be eliminated totally. Definitely there will be some kind of accidents, some dog, some person who is crazy, they might put their hand and something might happen. Okay, but apart from these cases, it should be fine.
Next question from Shivaji Garu.
Hello. Yes, sir.
Hello.
Yes, sir. Hello.
Am I audible? Hello.
Yes.
Yes, audible, sir.
Sir, I would like to ask a question about retrofitting of existing two-wheelers or bicycles, because bicycles are billions of bicycles in India, and same with the two-wheelers. So, what is the potential of retrofitting of the existing or utilizing existing vehicles?
Okay. So one of my friend, he is actually owning a startup in Bangalore. Okay. He himself does this. So he's currently still in the proto phase. There is, I would say, a market only in bigger cities. Okay. Like Bangalore, especially, I would say. But the moment you are going to say a tier 2 city like say Visakhapatnam, or you go to Bhopal or relatively smaller places, what happens is people don't want electric vehicles. First thing is that people want vehicle. That is the major criteria. In Bangalore, because it is relatively much advanced, in terms of technology, it could be anything, okay, relatively advanced. So what happens is the possibility of this business is more flourishable in Bangalore than other places. Okay. Second question was?
No, it's about what is the what we can say is the potential of converting existing vehicle. Is there technically, economically, it is feasible or not?
Yeah, I will tell you. I think it will cost you around 25,000 rupees to 30,000 rupees, give or take. Okay, to convert a IC engine two-wheeler to an electric one. So when I say electric, so you have the motor. Okay. You have the maybe I don't think so there is a gearbox, okay, but there is a motor, a hub driven motor, or there is a CVT based motor, and then you need to have a BMS. So I would say that getting a BMS is an issue. Okay. So for example, I mean, I'm just telling you, if you just want to give a try, you can try. So you have to buy the BMS, battery management system, from the supplier who is giving you the batteries. Okay. So if you want to do a project for you, what you can do is you can probably go to LG. Okay. You can go to Samsung and say, okay, I want so and so battery specification. Okay. And you give me the BMS. So battery and motor might not be so expensive for you, but buying that license for battery management system, that is going to be expensive.
Okay.
But I'm giving you a ballpark number. It is possible to be done in 30,000 rupees, give or take. It can be a little more than that also. But you could also remember that in 45,000 or 50,000 rupees, you'll get a scooter also.
Okay, right.
Okay, that's the reason I was talking about the market. Bangalore people will try. That's why Ather is in Bangalore. Okay, if you go to the other cities like smaller cities, people will not give a try.
Right.
It will take some time.
Okay. Thank you, sir.
Sure.
Okay, Nishal. I think that's all from his side. I think thank you very much for your wonderful lecture. You can give a very broad area about all the things, starting from history of EV to the advancement. Till now, generally we confine to only two-wheelers, but now we can give a broad scope. I think even more than 3.5 ton area trucks or even heavy vehicles, how can you able to make electric vehicle by have separate transmission system. Even you can give some solutions also for Indian side. How you can use BRTS roads to make it by putting some infrastructure. These are very good information for all of us. So thank you very much once again.
Thank you, everyone.
Ravi Kumar, 1 minute. Let me also thank him. Nishal.
Yes, sir. Adi, sir.
Thank you very much. Your presentation was excellent, and you have put in humongous amount of data into your presentation. And definitely, I can understand that that might have taken a lot of time out of your already busy schedule. And thank you very much for this service to your alma mater. And we are all proud of you. Thank you.
Thank you very much, sir.
Thank you, Nishal. Thank you once again.
Thank you. So shall I stop sharing?
Yes.
Yeah.
Stop.
Please start.
Thank you.
Thank you, everyone. Bye-bye.
Thank you. Bye. So participants, this is for today. And tomorrow we can have sessions from Karthik and Karu and Hemant, who are technical engineers from Design Tech Systems. So they will explore on design and simulation of electric vehicles. So we can again meet tomorrow morning by 9:45. Thank you. Thank you, Ananda.
Thank you.